Okay, new project time. So this is the old ZE40. So we've now got the ZE50. My wife has quite a long commute, so once a week she does about 150 mile round trips of 75 miles each way to the office. Sometimes does a little bit of driving around during the day. So driving this is a ZE40, first of the ZE40s. So the range on it, in the summer you can do 150 and stick the heating on. That's not really a problem, as long as you don't go too mad. But in the winter, it was getting a little bit patchy with if it was cold, having the heater on, you have to stop to charge, all that kind of stuff. So it's not great if you're doing a long drive, long day at work, that kind of thing. So yeah, she's got the ZE50 for that now. And yeah, interestingly, just in the sort of last week I was finishing the ZE50, this developed a really nice sort of bearing noise. Likely to be motor bearing, could be the reduction gear, but we shall have to see. Yeah, so let's have a good look at it. So it's also got a rather spicy knock on the front end. So these are known for having front sort of suspension issues. So if we have a look under here, the suspension, so in the ZE22s and ZE40s you've got 4-stud suspension. ZE50 2020 onwards is 5-stud, slightly beefier. If we get under here, so these lower arms, which is this piece here, it's kind of triangular piece with two fixing points in towards the car, and then one on the ball joint there. So these ball joints are kind of known for wearing out. That one you can't quite see. So they're a bit of a known weak point. So this was knocking at the front. It has been for a little while. So I've done the lower arms on it. That's one of them was really bad, but that didn't fix it. The other thing that's kind of known is these drop links, these suspension drop links that go up there. But it doesn't look like that either. I'm actually going to change them anyway because it's going to be interesting. And just so everything's sort of totally ready to go on this car, really. Yeah, so it doesn't look like either of those. But if I wiggle the wheel, which I can hopefully do with one hand, you should be able to hear it. Oh, yeah, hear that? So nice knocking noise. And you can usually feel if it's the ball joint kind of just behind there, but this is really central, and it looks like the steering rack's actually knocking. I have heard of this before on a Zoe, so I've got a steering rack to put on. I should have got that. I'll show it to you in the next video. It's just in the falling down garage behind the workshop. So yeah, that's a rather spicy knocking noise. And then we've got the motor bearing noise. So let's spin the motor and see what that sounds like, so we can have a listen, see if that gives us a clue. Yeah, I mean, it's done 116,000, this car, so it's not too bad. So let's put it in drive. I've got the, oh, that doesn't matter, because we've got the front wheels off the ground, and just let that spin. There we go. Once it starts, it'll, hang on a second, does it need a handbrake to be off? Yeah, so it won't do creep unless handbrake's on. Okay, so it's doing what's effectively creep mode. Oh, let's turn the pedestrian sounder off. There we go. And you'll hear it. Yeah. So a kind of quite spicy, whiny noise there. Just brake gently. There we go, just stop the motor from moving, put it back into park and turn it off. Yeah, so that's a kind of quite spicy, whiny noise. It sounds more of a low rumble when you're driving it. It definitely sounds motor when you drive, but could be the reduction gear. Have seen that. It's done 116,000. Reduction gearboxes can kind of lose their oil because there's a fill and a drain point, but there's no sort of you know, window. You can't check how much oil is in there without taking it out. So you know, if a bit's dripped out, you wouldn't really know. So it could have done some miles with limited oil. I did check the oil that was in there and it was okay, sort of refresh the oil just in case. It was quite dark, but then it had been in there a while, so kind of hard to tell really. Basically needs to get it apart, spin the motor and see what it sounds like, and if the motor's all right, then we put a reduction gear on it. So yeah, we've got to take the stack out of this Zoe. So this is going to be approximately, in terms of work, let's think about this. So we've got Renault say 8 to 10 hours to take the stack out. So sort of disable the vehicle, everything from under trays, and so let's go through it actually. Yeah, so sort of 8 to 10 hours for the stack out, about 2 hours to sort of strip everything down and check it, and then if we put like bearings in the motor, let's say it's the motor, which is most likely, and then we swap the bearings in another couple of hours. So we're into sort of 13 to 15 hours, I guess. So yeah, basically with these, so obviously get it degassed, that's the first thing. So under trays off the front, coolant out, reduction gear oil out, make the vehicle safe would be good, first of all. And then start stripping it down from the front, basically. So bumper off and kind of each layer until we're left just with the stack sitting there. And then go under, disconnect that from the battery so that we can pull the wires up onto the stack. So from the motor stack wiring loom and the big orange cable as well, main power cable. And then yeah, the motor stack wiring loom is disconnected from various points, earth points, fuse boxes, stuff like that, off the 12-volt battery. And then you there's 3 mounting points. So one at the back is like a kind of dog bone style vibration mounting at the bottom at the back, and then there's 2 mountings at the top. One is that one there with those 3 bolts, and the other one is on the reduction gear, but it's underneath 12-volt battery. So you do those, and then oh yeah, scuttle off all of that off. Wheels and drive shafts. It's one of those things I've done so many times I can do it without looking at the instructions, but you can see what the next step is when you kind of do it, but trying to think it through is more difficult without being in front of you. But yeah, so basically get all of that off, get the stack out, and then start stripping the stack down and see what we've got. And then we're just going to sell this car at the end of it. So yeah, nice little fun rebuild. I'll probably do a time lapse. I don't know whether I can get the camera in quite the right place here, but I'll give it a go. But yeah, nice little fun one you can follow along with, and we'll see how it goes. All right, cheers. Okay, just an update on the ZE40 rebuild. So yeah, obviously bumpers off, there's a crash panel that goes over there off, scuttles are off, coolant and oil is out, so gear oil, there's a little bit of oil in the reduction gear. Yeah, so that's out. I'm quite keen to see whether it is the reduction gear or the motor making the noise, because it's not the same as other motor bearing noises. It's normally sort of a low hollow noise, whereas this is more of a whine. So yeah, it's going to be really interesting to see. Yeah, cool. And if it's motor bearings, I might use a slightly different combination of bearings. Just test out a different one, because this is sort of our car. I can kind of test it out and then drive it for a bit longer. There's not a customer waiting for it, so that's fine, and see how it goes. Obviously the risk is if it's if it kind of doesn't last, then I'll have to take it back out again. But that's the way it goes with R&D on sort of 12-hour jobs. Yeah, so yeah, so drive shafts are still in, so I need to take those out. Obviously radiator pack off, just kind of letting the coolant finish dribbling out really. And then once the radiator's off, then subframe, which is that piece you can see there with those triangles bolted onto it, so that runs across and down there. So that can come off. And then there's other bits and bobs like 12-volt battery, rest of that ducting. There's a wiring loom that goes around the motor stack that bolts into various places, sort of earth points, that's part of it, and into this unit and on the sort of fuse boxes and stuff. So you sort of disconnect that from the car, and also from the main battery as well, and then sort of earth points, big earth points like that one. Yeah, and then you can basically unbolt the stack and lift that out with the engine crane, and then see what we've got. So yeah, not too bad progress. We're getting somewhere, and we shall see what happens. All right, cool. Okay, now we're getting somewhere. So basically that stack is ready to come out. So we got all the drive shafts off. Obviously the whole front end is off, radiator pack and everything. That subframe, aircon pipes. And there's an engine mounting at the back, that's off. The main high voltage battery cable is disconnected, and the BMS cable, so this is the BMS cable that runs down the stack and down to the battery, that's wiggled over. The main battery one's a bit heavy to sort of wiggle through, but that comes out with the stack. Yeah, so I'm hoping this is going to be fairly straightforward. This is the wiring loom that fits on the front of the radiator pack. That goes to a load of sort of sensors over here. One there, couple up there, and the brake fluid reservoir. Yeah, and one on the rad as well, outside of the radiator. yes, this is ready to come out. I'm really hoping this is going to be a straightforward Zoe sort of stack rebuild. You can have a bit of fun and games, but hopefully it's a case of sort of identify the noise, repair it and put it back in, and job done. That's the plan. It might have a curveball because these Zoes sometimes do, but hopefully it's fairly straightforward. So this is a 5AQ R90, just in case anyone's interested. So there's two variants of Zoe, the 5AM and the 5AQ. Yeah, and so this is the 5AQ, and on this one, unfortunately, to kind of do anything under the bonnet, it's all got to come out. But that's the way it is. So yeah, so next job basically, it's just get that stack out. So this whole wiring loom that goes round the engine is all disconnected from fuse boxes and earth points and that ECU. It's a plug on there and one in that fuse box, and yeah, is all of this lot. So that's all disconnected, put moved over there. This is the Renault procedure, done by the Renault procedure, and that stack is literally, you can swing it like that. There's an engine sort of like dog bone type engine mounting at the back, and that is off like a stabilizer bar kind of thing. That's off, so it's literally held in by there's 3 bolts there under the brake fluid reservoir, and that one there, which is sort of on the end of the reduction gear. So yeah, that's about ready to come out. Unfortunately, to get to the motor, so this is the motor. That's the reduction gear, 10-to-1, sort of more like a differential really, no clutch, just fixed reduction, and then with drive shafts at either side. So that's there, and then this control box is kind of like the charger, DC-DC converters in there, motor controller, and a couple of other sort of bits and bobs. That's all kind of in one box. AC compressor up there. So, but to get to this motor, you've got to take this whole stack out. So engine crane, get it out, and then we'll split that. So we've just got the motor, reduction gear separate, and that box off. Should we do that? Do we need to take that box off? Actually, we can just pop that reduction gear off that side, and then spin the motor and see where the noise is. Hopefully we don't then have to take that off. So we'll see. But yeah, we'll get it stripped down. I think that's enough for today. It is thoroughly dark. So yeah, I am done for today, but that is ready. Basically, next job is just to lift that out and start stripping it down and go from there. So, all right, cool. I'll catch you later. Cheers. Okay, so we've done all the boring prep, basically. And we're at the point where we get this stack out and we see what's wrong with it. So it's making a whining noise. These are common for motor bearings. So I've got one here, actually, that I took out. So this is one of the bearings. They've got two, they're different sizes for each end of the motor. Ironically, this one's got a rubber seal in it, and there's some debates as to what that seal is for. You can see there's a bit of corrosion on this one. These bearings have a reference number, and when you give that to big bearing companies, they say, that doesn't exist. Where do you get that from? And I'm like, okay, it's got the make on it, like the maker, but their bearings have like a size, and then they have like a letter coding which stands for different things, and there are sort of standard letter coding. So some mean like a rubber seal, metal seal, shield here, and what type of grease, what type of spacing. So you can get bearings that have higher spacing internally, which are for high temperatures, because obviously they expand a little bit and they're quite fine tolerances and whatever. So there's lots of different types as well as just the size. So the letters that should tell you the information about the bearing, yeah, and these are big like kind of multinational bearing companies all say, no, that doesn't exist. I can't say one of them. It's like, okay. And to be honest, I'm not sure I'd want to put the same as the original back again, because I've seen so many of these fail. So yeah, and as well, this one's got a rubber seal, which is really fascinating. There's lots of debates as to what that's for, but yeah, we'll kind of get into the actual bearings later. But yeah, next plan is get that out, get the reduction gear off, spin the motor and see if that sounds okay or not, because if that sounds okay, it's the reduction gear that's got an issue, which that can happen. But reduction gear issues I've seen tend to be more that they just literally break up inside, and like you get a crack in the side of it and it all physical complete break, because those reduction gears are basically just a few cogs and a kind of like a differential basically to split the power. So they're really basics. It's not, you know, and they're sitting in oil. unless the oil's all drained out, which it hadn't. But it's done quite a few miles, done 116,000 miles, so I guess anything's possible, but I'm kind of thinking it's probably the motor. So we'll see. We'll spin the motor. I debated whether I'd have to take that control box off, but I definitely want to do brush replacement on this. These motors have a wound stator, but they also have a wound rotor, so they don't contain any magnets. So, but to get them to move, obviously you magnetize a coil, but it's got to have something to push against, which would normally be a magnet. But in the case of a Zoe, the other side is coils as well. So it's kind of coils pushing against coils. So you've got to magnetize both. So with these, the rotor is like a kind of single wire loop effectively. So then that's got the start and end of it, and then it's got some brushes to get that power onto the rotor. So it's a brushless three-phase design. The stator is three-phase, got 3 coils. Yeah, it's just got that rotor, what's called excitation, to get it to move. So but that brush box cover, this is such a wonderful design. You can't quite see, but trust me, just in there is a black cover. We'll see it better later. And that's got the brushes inside it, and you can only replace those when the whole thing's apart. So this has done quite a few miles, so it kind of be silly not to replace those while we're here. You don't want to put everything back together and have a problem 1,000 miles later. And have to do sort of, 12 hours work again. So yeah, that's going to happen anyway. So we've got to strip all this down. So we'll have a good look at everything, see what we got, and then go from there. Right, let's do it. Okay, we got the stack out. It's on the floor, so that's good. Started using this pallet. I used to use the sort of wheeled trolleys, although I'm on gravel, so they're not that good. But I kind of do it like that now, because it's a lot more stable basically, and then I can get it far enough out with the engine crane and kind of break that down. I really need to get a new engine crane because yeah, before I had this sort of plastic workshop, my engine crane was outside, so I sort of thought, well, I'm not going to get a better one, and it's kind of an old one. It came from actually picked it up from this sort of dodgy East End like gearbox shop, one of those sort of suspicious looking places where you've got lots of guys and they're working furiously, and there's like gearboxes stacked up in the corner everywhere. Sort of fascinating place, but yeah, this was one they didn't want. It was cheap and I was keeping it outside, so I thought, oh, I'll just do. I didn't know whether I was going to keep doing this, so but having kept doing it, I think I need to get a better one. So this is out. It's quite a heavy lump, this, I should say. Please only do this if you're suitably trained and equipped. I'm level 4 EV qualified, and it is a heavy lump. As this was coming out, this mounting was kind of a bit close over to one side, and it sort of got a little bit stuck on that subframe, which kind of happens. So I sort of kind of grabbed it and went to move it over, and I basically slammed my thumb between this as it jolted between that and the corner of that thing, and yeah, I'm not going to show you my thumb. It's not looking too good, but yeah, no, just yeah, only do this honestly if you're able to deal with the high voltage, because obviously you have to do a high voltage shutdown. You also have to verify that the high voltage shutdown was successful, that the high voltage has gone, because there is a period of time where that drains down. So you have to be able to test it to confirm that it's definitely shut down. And doing a high voltage shutdown in a Zoe, you come into close proximity to high voltage, and that is unavoidable in a Zoe. Okay, so yeah, please don't do this unless you're confident with those things. So yeah, so this is out. So what I'm just going to do is I've got the stack on a bit of wood there, so that this reduction gear end is sticking up a bit, because you basically, it's a little bit tricky to get this off, and there's a rubber seal and then a fibre washer just inside the gearbox where the reduction gear, where the motor shaft sticks out. So got to be really careful with that. So yeah, just starting to take off the wires. So that's the parking sort of parking lock and gear selector switch. So as you move the sort of gear selector in the inside, it physically moves this, and that's got the parking lock, and then that's a sort of sensor so that it knows what gear you've selected. So yeah, just taking all of that off, take the water pump off, and then we'll get that off and see what the motor sounds like, see what's going on. Right, cool. Okay, cool. And so now we're getting somewhere. It's always a little bit of fun to get off these because it's air cooled. So this, where I've got the cardboard here, is an air cooling duct, and the air goes through there, and then it can go sort of through the middle of the motor, but around the outside,
and you probably can't quite see, but in that dark hole, you can just about see there, see that oval gap. So that actually goes through the motor, and then there's a vent hole on the back there. So, and then there's a duct, and that vents it down into a hole in the under tray. But because it's air cooled, and this is aluminium, so the air can come in here, so you always get a bit of this aluminium powder corrosion. And then, so all up here, this is not the worst I've seen by any stretch. This is not too bad. And then obviously the lining up of the motor into the reduction gear is absolutely crucial. So it's got these locating steel pins here, so they're harder, one there and one down there, and then they locate into holes in the reduction gear, sort of up there, and then one down there. So yes, that always makes it a little bit difficult to get off because it's so firmly on, and then the sort of dissimilar metals corrode a little bit. So you've got the aluminium case there, but you can see there's a little bit of rust that's come off that locating pin. But yeah, so always a little bit of fun and games, but that one's off, and I've given it a little spin, and yeah, have a listen to this. Got to do this one-handed. We definitely don't want this stack tipping over, so let's give this a pull, and with the dodgy thumb. Yeah. So I think we found the issue there. So yeah, the motor sounds pretty terrible, proper bearing noise. So it's actually, it kind of sounds like both bearings. So there was a sort of high pitched, what sort of rattle almost. And then there's the low rumble noise in the background. I'm trying to remember which one's which, but I've seen more of one bearing go than the other. Yeah, I think it's the other end that tends to go, and that one's the one that makes the low rumbly noise, because I did kind of partly suspect the reduction gear because it was more of a whiny noise. But yes, I mean, that motor obviously sounds terrible. That needs rebuilding, there's no question about that. Not all kind of motors are good to be rebuilt, some have other sort of issues. This one's interestingly got a little bit of wear on these splines, so you can see how much of this is sort of in contact with the teeth inside the reduction gear in there. But I think that's not bad, to be honest. I'll have a look at a few others. I've seen far worse on that. That's not too much of a concern. So yeah, given it's 116,000 miles, I think that's not too bad. But you can see it's kind of a little bit shiny there. But yeah, I will review that as well in more detail. What I'll probably do, actually, sometimes it's really hard to see sort of visually, but if you take a few pictures, you can zoom in and really get it in focus, and then sort of analyze how much material has sort of come off. But we'll have a good look at that. Got to have a good look over the motor, just see if it's got any other concerns, basically just because this is a long job, and the whole idea is to make it a reliable car again. So yeah, so this car's never broken down, which is good. And there's a sensor here, rotor position sensor, so you can get enough movement with the bearings that the position here, so there's a ring in here. I don't know if you're going to be able to see, but there's a ring in there that moves in and out. Not very easy to see, but within there, right inside there, attached to this rotor shaft is like a kind of oval ring, and then that's rotating inside this sensor, and that's how it knows the position. So as the motor controller fires those phases, it expects it to move, and then it can kind of get that response. And if that sort of has issues, then yeah, then the car will stop moving, as the one I've got outside does that. But yeah, so that's quite cool. So we need to get all this rest of this box off, have a good look over this. We need to replace the brushes as well, but yeah, just kind of look at everything on the motor and just see if there's any other concerns that might mean we need another motor. But sort of so far so good. So yeah, so that reduction gear should be okay. They tend to be pretty reliable. They are just a few cogs and a sort of differential portion, so there's not a lot to them really. They take some oil, they're quite basic. So yeah, that's our issue. Got to continue to strip this down, but we're getting somewhere. All right, cool, cheers. Okay, so Zoe 40 motor repair. So this car's done 116,000 miles, started making a noise, sounded like the motor, but it was a little bit high pitched. The motor, just for reference, motor bearing noises tend to be a sort of hollow, low noise. It was a little bit high pitched, this one, so I did partly suspect the reduction gear. So these vehicles have it's about a 10-to-1 ratio fixed reduction, and it's like a reduction and then diff to split the power out to the drive shafts. But that, taking it apart and spinning the motor like I did in the last video, we can hear that's making a horrendous noise. So that's definitely the cause. So I've rebuilt a few of these motors. Ironically, this project was slightly delayed because the garage sent me a motor to rebuild. I've done a few rebuilds, and I'm sort of developing the method, and it's not a short job, I have to say. The first one probably took me a day, and I can do it in a few hours now. But I have found not all motors are kind of really suitable to rebuild. You can have other issues. So like this one's got a little bit of wear on the output shaft. You can kind of see that that's the part that doesn't come into contact with the cog on the reduction gear, and then this bit does, and it's got a little where it's a little bit more shiny. It's kind of worn a little bit there. I've seen one where they're really worn down. And there's various other issues. So you can actually have movement on these motors. So the bearing, so it's got a bearing at each end. The bearing in here can actually lock up, and then the whole thing moves, like the outer race rotates and it grinds the case, and then this shaft can wobble. And then that causes an issue with this position sensor. So this is the rotor position sensor. So it's got a load of coils there. And if you can just about see in there, you can see there's like a lobed metal ring there that gets closer and further away. If we get a bit closer, hopefully it will focus. Where are we? Oh, there you go. You can see it moving, and so it's kind of an ovaled ring. I actually got one of those. Hold on, just to show you. Yeah, so this is that metal ring. They do tend to get a bit rusty, these as well, because they're just bare metal. So yeah, that rotates, and then the motor controller can see like the reflection of that signal, and it can know the position there. So if that shaft moves, that sensor loses the signal, causes it to break down. Obviously, if that bearing is moving, because where the bearing sits has kind of gone oval, you can put a new bearing in it, but the new one's going to move as well. So I've had about a 50-50 ratio of motors that are suitable to put bearings in, that I'm happy to rebuild for someone and then put them in a car, because it's a long job to do this. You know, sort of 12 hours labour. You don't want to give someone a motor and it not be any good. However, you can kind of tell based on the characteristics of the symptoms with the car. So this car started, drove, charged, everything. It just got a bit noisy. So we know that everything still works, because this was our car. I mean, basically I said, right, we're not driving that anymore, sort of thing. No more long journeys, and then it got bad, and it's like, right, stop driving it, kind of thing. If you keep driving them until they break down, it's a lot less likely you're going to be able to put bearings in it. You just have to get another motor. Yeah, it is a long job. This, it is a long job. You've got to be pretty patient to want to do this. So in terms of the bearings themselves, there's a few tricky things about doing the bearing swap. One is finding bearings that have the right characteristics. So it's got a 10-to-1 reduction. We know that, 10-to-1-ish. Some information says 9.5, some says 10, but let's call it 10-to-1. So the motor is spinning 10 times wheel speed, so you can work out the motor speed, but it's spinning really fast, and that's to get it within the correct efficiency window of the motor. There's obviously a place where it wants to spin, and the reduction gear has been designed around that and the sort of expected wheel speed. So it's quite a high speed, and if you get a standard bearing, that bearing is not designed for a continuous speed output of that motor. So I know some people are rebuilding them and putting in bearings which are actually not technically capable of that speed. So it's about 11,000 RPM the motor gets up to, but people are putting in bearings which are max kind of 7,000 RPM. But on the data sheets where it says 7,000, that's under certain test conditions for a certain period of time, and it's kind of like, okay, well, 11,000 RPM, sort of 75 miles an hour, let's say. How long is it going to continuously do 75 miles an hour? Well, if it's a Zoe 22, it's going to do that for an hour max, because then it's going to run out of charge. And even on a Zoe 40, it's going to be 2 hours. It's kind of up to you. The bearings I use are rated for high speed, because I'm not, even though some people are doing it, I'm not happy to do that. It's a long job. You've got to do it properly. So speed is one factor when trying to get hold of the correct bearings. Another one is, this one is held in with a snap ring. So you can see this one's actually corroded a bit on the outside because this is steel in an aluminium case. So a nice bit of sort of effective dissimilar metals. But yeah, so this one's got the snap ring that holds it in. This is the original snap ring. Trying to get bearings of the correct speed with the snap ring groove is not easy. I've gone for sort of a metal shielded one because they have a higher speed rating. Although they come with this snap ring, which just has a cut in it, doesn't have any legs like this one, and doesn't have that little indentation. So currently these are a massive pain to put on, because it doesn't hold. See, if it had that cut like that little, yeah, like that, it holds the circlip pliers in place. Whereas that, it's an absolute nightmare. So currently hunting for more, for better snap rings for them. The one at the other end, yeah, has this rubber seal in it. So yeah, it's really difficult to tell what that rubber seal is for, and trying to find a bearing for that end that's got the snap ring in it. It kind of, when I was looking, it kind of came down to, you can actually have a much higher quality bearing without the groove, so without the rubber seal, or you can have one with the groove, so you can put a rubber seal in it, but it's not coming from one of the bigger manufacturers, sort of thing. It's like a smaller, you know, less well known. So it's just a very difficult decision, really. If you don't have the groove, so if you don't worry about that, you've got a little bit more choice. So I kind of settled on these metal ones, although I've subsequently found this rubber sealed, high speed rubber seal one. So I'm going to give that a try. So I think with this motor I'm going to put these two in it. And this isn't going in a customer car, this is in a car I'm going to drive around, so this is kind of a bit of R&D at this point. I've used this pairing of these two a few times, and that's okay. But yeah, we shall see. So yeah, all of those things have to be considered. There are, with bearings, you can buy really expensive bearings, but some are sort of £150 each, and you're sort of thinking, this is going to cost a lot on the time and everything. So it's sort of like, does it make it cost prohibitive, really? But yeah, we shall see. We shall see. It's kind of up to everyone to make their own decision, really. It's not yeah, it's not a simple process, that's for sure. But yeah, we're going to get down to it. So basically, we've got to get this box off. The motor wires are connected underneath. Do that and strip this off. There's got sort of a bracket there and a couple of bolts down like that either side. Undo the wires, take that off, and we can disassemble this motor. Basically, I've done this a few times, and I'm kind of getting there with it. There's always a bit of aluminium corrosion which needs cleaning up. This is not too bad, but when it comes to getting this cap off, because there's a cap that's bolted at that end of the motor, there's always a bit of corrosion in there, and that needs cleaning up as well. So yeah, and you've got to, although the corrosion can hold that cap on quite tightly, and you've got bearings, and those bearings have rusted a bit as well and made it go tight, you've got to be really careful and not put too much force into this motor, because you might damage it, basically. If something doesn't exactly line up, it's just not going to be, it's not going to be reliable. So yeah, it's not for the faint-hearted, but if it's something you want to do, that's entirely up to you. But yeah, we're going to get into that next. So yeah, cool, right, that's the plan, and we're gonna do it. So yeah, let me know if you've sort of attempted it, if you've done different things. Obviously this is just one way of doing it. Different people are doing it different ways. I'm gonna get a metal bracket welded up for sort of assisting with part of the process, because it's not easy. There's a few different ways to do it, but just in terms of disassembly and then refitting the new bearings and stuff. Actually, interestingly, I've kind of done them in the summer, and now it's a bit cooler. It's actually a slightly different process now. The ambient air is cooler. I mean, if you're in a heated workshop, it doesn't make much difference, but I've just in my sort of pop-up workshop outside, and the case of the motor, the one I did yesterday, it was noticeably different putting on the bearings. Actually fitting the new bearings was slightly easier because I heated them up, and then you can put them onto the rotor easier. But yeah, it's slightly more difficult putting the rotor back into the case because of the fact that the case is just a tad smaller, because of the sort of thermal expansion, or thermal contraction, I guess. So yeah, it's still good fun, but yeah, follow along and we'll get this motor apart. All right, cool. Okay, so let's start stripping this motor down. So that's the control box, that's off, and that's where the motor wires go, underneath there. Yeah, so quite an interesting construction, I think. So where it's got the coils, the sort of wound stator, so you can see the stator around the outside there, and then you can actually see the rotor coils there. There's a little, I've got a bit more light on now, so you can see that rotor position sensor a little bit easier. That's quite cool, that ring, that lobed oval ring that rotates in there, quite interesting. I always love it when I see this. So there's 5 holes for this rotor position sensor, but it's only got 3 screws in it. The early ones actually had 5 screws in. Bit of Renault process improvement, and those ones aren't even tapped, so you can't even get some spare ones and put them in there. But it's only absolutely crucial and critical for the function of the vehicle that there's no movement in this. So Renault just yeah, didn't bother with those 2. But yeah, Renault for the win. So yeah, so it's if you spin it quickly, you can kind of hear it's not too good there. So this is the wiring, so I've got to take that off. I've got to get this sensor off as well. So start stripping this down. So this is where you've got the brushes are in here. Should we just take that off? One moment, please. Let's just strip that off. So we can show you in here. That's the wrong thing. I'll be back in a moment. Okay, there we are. So got this brush box cover off. So at this end, we've got these are the phase wires. Well, this is actually the neutral, I believe, on that end. Yep. So that's the negative. So it's like a kind of star configuration, I think it's called. So these windings are all connected to like a kind of central point, and then that central point is connected to this neutral. It's an interesting configuration because if you look up wiring for 3-phase motors, you get 3 wires. They kind of look like that, and if they've got magnets, they don't have that either. So you kind of just have 3 wires. You might have a position sensor, obviously that's at the other end. So why has it got all this extra stuff? So it's got a center point, which isn't actually required for the motor to move. That's actually because of the chameleon charging system that they have on these Zoes. So basically these are your phase windings. You can kind of go between any of the phases to make it move however it wants to fire it. But in terms of actually the chameleon charging on the Zoe, so the Zoe charging is quite complicated. It doesn't have a single onboard charger like other EVs. It actually uses the motor coils for boost conversion. So when it takes in AC, and all Zoes can do 22 kilowatt AC, and it doesn't have an onboard charger with big coils to do voltage boost conversion, it uses the motor windings. And it basically needs that neutral point to be able to access the parts it needs to do that boost conversion for charging. If you get a chance to look up the chameleon charging system on the Zoes, it is actually quite fascinating. So it's using the motor controller, so like the transistor block in the motor controller, to fire the motor coils and use the coils in the motor for boost conversion instead of having to have an onboard charger with coils. And basically to do 22 kilowatt AC, you'd need a load of big coils, and you've got some sat there. But to do that, you also need to be able to make the motor not move, because obviously if you put power in the motor coils, if it had a magnets on the rotor, so permanently magnetized rotor, the motor would move. So when you plugged it into charge, the cord would move, which would be a bit problematic. So they have a wound rotor. So this is the end of the rotor shaft, coils around the rotor that end here, so just like a single coil effectively around the whole rotor, hence you've just got 2. And then these are the what are called the excitation wires. So basically the motor has to be excited. So these get kind of like just a little tickle of current. You can kind of see from the thickness of the wires, they're not going to get a lot, just to make them magnetic. So that's just a single coil around the rotor, and these are the real power ones that are pushing against that or kind of making the rotor push itself round effectively. And these are obviously a lot smaller because the stator is all the way around the outside, whereas the rotor coils are just in the middle. So interesting stuff anyway. This is a temperature sensors, if you're wondering what that is. And so this is the brush box. So to get power onto that rotor, it's got copper slip rings and carbon brushes. So people often get a bit excited when they find out the Zoe's got carbon brushes. Oh, it's a DC brushed motor. Is it the 1980s? No, calm down. It's a 3-phase AC motor. It just happens to not have any magnets, so no rare earth magnets and stuff. Yeah, so just lots of copper. So I haven't taken these off yet just to show. So we can see we've got quite a bit of brush carbon material sat in there, but kind of consistent with the mileage of the vehicle. Those slip rings look okay. There's a little bit of wear on those, so a bit of a lip on there. I've seen these really bad, and one I didn't rebuild was because they were really bad, but that looks okay. Let's just get a good shot down there. Yeah, they're still nice and central, those. Tiny little bit of a lip that I can feel, but not too bad there. So I think I'm so far happy to rebuild this motor, happy to carry on. I mean, yeah, as I said, it hasn't broken down, but you know, something could be marginal, and this is a long job and we want the car to be reliable. So it'll be interesting to see how much wear these brushes have got, considering it's done 116,000. But yeah, they need changing, because the control box fits here. You can only access these when you're in this condition basically, and everything's, you know, when the car looks like this, and the control box is over here. And obviously, so if you later had a problem, if you had a problem with these brushes in 6 months, yeah, it'd be a bit stupid not to obviously replace them now. Those brushes are about £100 from Renault, so not vastly expensive. And yeah, need doing, but yeah, all of this needs cleaning up. These brushes need taking off, so I'm just going to get them off and we'll see how much wear they've got. So that'll be interesting after 116,000. All right, I'll just get those off. Okay, so we've got these brushes off. So you can see there, there's quite a bit still on. I've got a new set actually. Well, actually I haven't got any new sets, but this is the lowest mileage set I've got that came off a really low mileage damaged motor. Yeah, so you can see there kind of where they get to. I think effectively, annoyingly, these are a slightly different design. When you, so these are the original brushes. If you go and order them, they're brown. I don't know why they're brown, but they're brown on all the ZE40 motors, and then when you order them as replacement for sort of ZE22 or ZE50, they're brown as well. But they are the correct ones, and they sort of go up to about that lip, so slightly sort of a quarter of the way into this edge piece. And you can see there, so interestingly, one's got a bit more wear than the other. Maybe that they sit at a slight angle. But yeah, that front one, I mean, are they all the way out? Yeah, I think they're kind of all the way out of there. Hard to see. Oh, that one is sitting in there slightly. It doesn't seem to want to come out. But yeah, that one's slightly in there. So that back one, let's say that when it's new, it's sort of, yeah, slightly higher than that one. So there's still quite a lot of material left on there, isn't there? I mean, that's, what would you call that? I'd say there's a 80% still there, something like that. I mean, 116,000. These are designed for the life of the motor. I mean, I could put these back. I think it'd be a little bit foolish, wouldn't it? Probably. I mean, these are off a used motor. So I bought a motor stack and the motor was damaged basically, so just stripped any useful parts. And yeah, these can be reused. But you kind of think these could as well. I mean, there's still quite a lot on there. Be a bit cheap, wouldn't it? I mean, yeah, really, at least we need to put these on or put some new ones on. But yeah, I mean, it just goes to show those brushes could do, I mean, they should be able to do far more than it's done, 116,000. So yeah, they'd be good for quite a while, to be honest. So yeah, just thought that was interesting. This is a brush kit. Comes with a little plastic cover, so when you get them there, sort of push down, and then this goes over them so that you can push that over and take off the plastic, and then they kind of pop out, and it just stops basically the brushes from catching on these rings as they go on, because they are carbon, they are quite soft. But yeah, interesting. So I hope that's useful. So next jobs, so I've taken this cover off, which is that one that's laying across there, because these brush wires basically wiggle through this hole and then out through here, and then they're held on by that plastic cap. So you get that off to take the brushes off, and obviously you need that off as well to get the cap off. So this end is kind of ready. I've got to get this wiring off, get the sensor off the other end, and then we can actually crack this motor open and replace the bearings and have a feel of the old bearings. Last one I did, one bearing was far worse than the other one. It's always interesting to see whether there's variance in which bearing's wearing or whether it's one end. It'd be nice to know why it wears out, really, because the bearings should last a lot longer. I mean, like, these carbon brushes are designed to obviously last a really long time. I don't think it's poor bearings, to be honest. I kind of have a feeling that it's sort of an applicability issue, as in the bearings are good, but they're not the perfect fit for this situation. Because at the end of the day, this is like an industrial motor, basically. It should last a long time. So yeah, something like 80 kilowatts, I think, in this variant. Yeah, I mean, realistically, we should be able to make motors that are reliable for a long time. But yeah, it just seems to be a bit of a bearing issue with this one. Whether it's alignment, I don't know. Interesting. Let me know if you've got any thoughts. But yeah, that's what the brushes look like. So that's where it comes as a kit. Those ones are pretty good. That's about where they are brand new, to be honest. Yeah, and these ones, yeah, that worst one's probably, yeah, that worst one's probably 70%. I mean, it is sticking in here a little bit, so yes, or 70-80% still left on the brushes. So yeah, they'd go for a long time. It's a real shame about the bearings, really, isn't it? Because the rest of it would be all right. But yeah, all right, cool. Catch you later. So I got this motor kind of with everything off. So the rotor position sensor is off there, and then down this end we've got this plastic kind of cover off that holds the wires, brush box cover, brushes off, and we're basically ready to then open it up. So I'll get it popped open and then show you what's what inside. Yeah. These are quite interesting motors in that they're air cooled. That's something I haven't actually mentioned. I talked about sort of different bearings and speeds and things. One of the other things, because they're an air cooled motor, so the reduction gear that's here has like a gap in it, and the fan blows down into it, and that blows through the motor. So there's some cooling holes. Yeah, you can see them around the edge there, around there. So all the way around the stator, there's cooling ducts, and then kind of through the motor as well, you can actually get some cooling, and then that exhausts through that there, and then there's a duct that pushes it down and into the hole in the under tray. So because of the motor being air cooled, you obviously can't use an open bearing because there's a potential for dust and moisture, because there's no kind of like filter on the cooling air that runs through the motor. It's hard to tell how often the motor actually turns on that cooling. So we don't really know how much air gets blown through the motor, but you want a bearing that's not going to get a lot of sort of be affected by dust and moisture, basically. We do know, I mean, we get this corrosion. The sensor had a bit of rust on it. Just grab that. So this is the rotor position sensor. So there's a bit of surface rust on there, and also the sort of sensor ring. They're prone to a bit of rust on. This one's actually not too bad. These are cheap to buy, by the way. Put a new one on. Yeah, this one's pretty good actually. But yeah, I've seen these with quite a bit of corrosion on. So we know that they must get moisture in, basically. I mean, it's a big lump of metal. It's outside, obviously, so it's going to get condensation on it. So these are subject to dust, a bit of moisture, condensation, that kind of thing. So you've got to have a bearing that's going to be protected against that. And when you look up the specs, the metal shielded ones are not as good. Well, they're better for high speed. They're not as good at keeping out dust and moisture as the rubber seal ones. So these bearings are a real fine line. That's why choosing a good bearing is tricky, really. You can see it's pretty dusty in there. We'll have a bit of a better look at what they're like when they come out. But yeah, you can see there's quite a bit of dust in this. A bit dark in the light. Yeah, you can see how much dust is built up there. That's the original snap ring. Whether it comes from the factory with those two legs, I don't know, really. Kind of annoying, but yeah, that's got to be released. But yeah, interesting. Yeah, cool. So yeah, I'll get this apart and show you in a bit more detail what it looks like. All right, catch you in a bit. Okay, so we've got the end cap off, so we're getting somewhere. Let's get some light on. So they are a really interesting design, and part of the difficulty of doing these bearings is knowing why they've made certain design choices, because you've obviously got to make choices if you're going to replace these bearings. So this end is particularly bizarre. So this is the bearing that's got the rubber seal. It does spin, but doesn't sound too good. And then it's covered in all this material, but whether that, it kind of looks, it looks coppery, that, but I think that is carbon dust from the brushes. And then the cap, so just inside, so this is the inside of the cap that fits over that shaft. So this is the brush, where the brushes go, the slip rings, we just covered them up to protect them with some tape. So it's got this sort of spring, like steel spring, okay, kind of weird. And then obviously that carbon dust all collects in there. But yeah, just a really odd design. So why has it got this rubber seal? Why has it got this spring? Is that to push the bearing? But I mean, the bearing is so tight on the shaft, there's no way that can move, you know, in and out. So yeah, just really odd, and it's reasonably tight in here. So yeah, let me know your thoughts, really. So you kind of got to make some assumptions when you're doing this. So obviously I mentioned earlier that if you don't worry about this rubber seal, then you've got more options, and if you look at the bearings, you'll pretty quickly find that out. If you go with this groove with the rubber seal, you're really going to have limited options, but it's entirely up to you. You know, different people are doing it different ways. And yeah, it's difficult to know what's going to be reliable long term, because I don't know of anyone who's actually put serious miles on one of these motors. I've done, you know, reasonable miles on some of the motors I've built, but not, you know, not sort of 50, 60, 70,000. But yeah, we can really see right in, see all the rotor windings there. So this is all the stator. I always think this always looks so rough and ready. There's actually a video, if you search on YouTube, of Zoe motors being built, but yeah, they kind of use these cable ties. You can see snipped off bits of cable tie there. They use cable ties to hold it in place, and then there's sort of string then holds it in. But it always look really sort of rough and ready kind of thing. But yeah, they obviously work. Just these bearings. So yeah, that one's not too good. Be interesting to see what the other one's like. So yeah, I need to get this rotor out, and then we'll see. All right, cool. Okay, check this out. So we've got the rotor out. So I'm kind of adjusted each time I do it with this, but it's really easy to damage it as you go. So inside the motor, it's got like these kind of like shims almost. They're all lined up metal. Trying to get a good shot of that with the light and the camera, but yeah, hopefully you can see that. Oh, you can kind of see there that they're sort of lined up. And if you look over there, I've separated them slightly. I'm slightly difficult to see because of the light. You might be able to see there, I've sort of pulled them with the rotor. The rotor is really heavy. The whole motor together is probably about 55, 60 kilos, and I reckon that weighs 20 kilos, something like that. Yeah, so you're trying to get that out, but not damage that. So yeah, it's certainly not an easy task, but that is out. So we've got the two bearings still on the rotor here. I kind of vary the way I do it, but interestingly, that one spins freely, but you can probably hear he's making a bit of noise. Hopefully you can hear that, but I can certainly hear it. Just a little bit of noise, quite a lot of play in that as well. A lot of sideways play, and then this is the other side, so the sort of output shaft that goes into the reduction gear. And that one, yeah, is really stiff. It's actually quite notchy as well. If you get to certain points, it kind of like locks up a little bit, and you can see this is aluminium corrosion, sort of corrosion between the aluminium and steel there, and then there's bits of rust on it as well. So yeah, which is all of that's kind of damaging where it's sitting as well, and that's quite bad actually, that bit. So yeah, so I next need to kind of look over it all, clean everything up. All these surfaces all need cleaning up, because as you put the put it back together, these are going to cause it not to be totally square. But it's out, and that's what it looks like. Hopefully that's interesting. So next job is obviously to replace these bearings. So get these ones off, put the new ones on, clean everything as much as possible, so that everything is sitting correctly and totally square. And because it's spinning so fast, it's absolutely crucial that everything lines up. So sort of all these surfaces, and so where we've got like, so this is the cap that goes on the end, where we've got all of these, you know, everything's got to be cleaned up. And it's got these sort of locating pins, you know, it's all got to be totally as clean as you can be, but without, so, you know, you've got to clean that surface, but you don't want to take anything off that surface, because you need it to sit back exactly how it was. So hopefully that's interesting. That's what the inside of a Zoe motor looks like. So yeah, we can really see those stator windings clearly, and they're slid in, those in between those bits of metal there. Quite a fascinating design, really. Yeah, and that's what the rotor looks like. So it's got these big fat metal parts, and then the windings around there. So yeah, quite cool. But yeah, interesting that that bearing's noisy but spins freely, so it's obviously not totally happy. Yeah, and then this one's really quite rough. I can try and spin that, but it stops itself, and I've kind of moved it a few times, and yeah, it does get kind of stuck in places. So yeah, really not very happy. But both bearings there, which is kind of interesting, so not just one. Yeah, and so next job is to get this all cleaned up, put it back together. Hopefully this one will be all right. If not, I'll have to put another motor on it. But yeah, we shall see how it goes. All right, catch you later. Okay, we are now fully disassembled. So the only way is up from here. So yeah, getting the bearings off the shaft. One of them was really well stuck on. I don't know if it's the sort of ambient temperature, but you'd think that would make the shaft smaller anyway. But yeah, with a sort of bearing puller, 2-foot lever bar, you know, gun on the bearing puller, just yeah, you certainly got to be brave to do this job. I think I was stupid, one of the two. So yeah, so that's the one on the output shaft on the sort of other end of the motor. Yeah, so and then that one, yeah, it doesn't look too pretty, does it? But yeah, that's the one that's sort of quite notchy, yeah, and quite bad. And then the other one's the one that's covered in the or was covered in the kind of brush material, but spins quite nicely, but has got loads of play in it. So yeah, not too good, and it's filthy. Right, so I'm going to get the new bearings, get them on here, get it back together, and then see what we've got. So far, I think this motor will be okay. At least it's just going in a vehicle that I own, so I can drive it around for a bit and just make sure we're all happy before I decide what to do with it. So yeah, all right, cool. So I'm going to get my new bearings and get them on here, and basically get that back in, and then see what we've got. All right, cool. Okay, home straight. So put the new bearings on the shaft, got the shaft in, and then got that circlip back in. These, you can kind of see these circlips are really annoying. I haven't got any legs, even if it's just had a little notch. I'm kind of tempted to Dremel a notch, or I'll try and find some better circlips, I think, because that's a pain in the backside. But yeah, anyway, that one is in. And then on the other side, you can see we've got that one here. So yeah, we're trialing this one. This one's got a little bit more resistance because of it just being that rubber shield, but we shall see. So I've cleaned up all of these surfaces, and similarly around the other side where the bearing sits, because like the old one, that's that one, isn't it? It's got, like, it's pulled the aluminium there, it's sort of deposited rust on, you know, all these things. Ooh, get in focus there. All these things need cleaning up. But you also got to be really careful because it's aluminium, it's quite soft. So if you give it a good, you know, a good scrub with some sandpaper, you're going to take off too much material, and then the bearing is going to be able to move. So it's a real balancing act of cleaning it up but not actually removing any material to affect how it works. So yeah, fun and games. It's all part of the job. So yeah, I've got that one on there. Basically got this cap all cleaned up, got this spring back in. So I find this spring really odd. So effectively that's pushing between the case, and it's quite a stiff spring. There is some give, but yeah, I'm pushing against the outer race. But the outer race is held in this case anyway, so it's kind of it goes on, it's snug, but not mega tight, I would say. If everything's all square, it goes on relatively easily, this cap. You can just do up the bolts, so that's fine. Just sort of present it up there. The bolts go through and that pulls it on. And you don't have to put a lot of force into that. So it's not mega tight. But yeah, that spring pushes on the outer race there. But why? I mean, on the other end of this shaft is a bearing with a circlip holding it in. So, I don't know. Does it just keep the rotor forwards? But, yeah, I fail to see how that spring has enough force to push the whole rotor forwards. Very strange. I don't know. Maybe when it's brand new, it keeps things in the correct position. But as I say, it's got a circlip on the other end. It can hardly move anyway. Very strange. If there's a motor design expert out there who can enlighten us, that would be fantastic. Because yeah, a few things are a bit confusing. Similarly with that rubber seal, I mean, what's that sealing? Is that keeping the brush, you know, where we had all that material from the brushes? Is it keeping that out? But then it's basically solid. You know, the bearing is snug in this housing. There's not really a gap, but is that just to make sure that the brush carbon material can't end up in the motor? I don't know. So yeah, let me know what you think. But yeah, so I'm going to get this cap popped on and then just check it spins nicely. Right, catch you in a mo. Okay, so the cap is back on. So I had to clean up all these surfaces because they're a little bit corroded, but that is on and it's all looking good. So let's spin it and see what it sounds like. All right. So there we go. Sounds pretty good. You can just about hear the bearing. You can hear that one. That's the rubber shielded high-speed one at that end. But yeah, obviously a lot quieter than it used to be. So that is pretty good. Haven't put the sensor back on, but I've got to pop that sensor on and put the brushes on here and the brush box cover and also the plastic cover for the wires. But that is pretty much ready to go. So I am done for the day, and that is ready to finish off and to get that control box back on, get this stack built and put this back in. I've also got to do the steering rack on this car, but that's quite accessible now that the engine bay is empty. So I will get that done as well, and yeah, we'll get this car back together. Right, I'll catch you later. Okay, so steering rack time. So this Zoe had a nasty knock at the front end, which is not uncommon. If you've got a Zoe, front suspension is quite a weak point. You can have issues with the lower ball joints, which if I go around here, the ball joint, so behind the disc is this joint, sort of just in here, and this is the lower arm, this sort of triangular part. And they can be quite expensive to have replaced, but those ball joints are a real weak point, cause a knocking noise. And then this, what's called a drop link, that one that's bolted in there and just bolted in there. So they can make a noise. But this Zoe had a real bad front end knock, and those parts were all replaced, and it was still knocking. So I believe this to be the steering rack. So I've just swapped this over. This is the old one. So this is literally taking the steering input from the steering column and then pushing these track rod ends in and out, literally to move the front wheels. And this is just purely mechanical, this part. All the sort of like assistance, power steering is done on the sort of steering column. Makes this a little bit easier, but I've just swapped this over. So where does this sit? So normally this Zoe would obviously have a motor stack in it and a bumper and all that kind of stuff, radiators. But we can see this quite well because nothing's there. So if we go a bit closer, I'm just going to sit on this motor. Oh, not the most comfortable. So here's our steering rack. So that goes up in and bolted onto the steering column, and then it's got the track rod end sticking out there. So that's on this sort of aluminium subframe, which is behind the front subframe, which is that one over there. So that part there would normally sit just in here, kind of an extension there, and then that's got the radiator on it, and then obviously the motor and yeah, motor stack in there. So that one's in there. And the other interesting thing is this is where the anti-roll bar is. You don't normally get to see this. So where I was saying this drop link is bolted on there, so this is all just loosely back because I've just been taking it all apart. So this is the anti-roll bar, which goes over here behind the steering rack, literally goes along there and over there and to the other side. So this provides stiffness, but it's obviously connected to both wheels, so it's a kind of dynamic stiffness, as in when you're going around a corner, what's happening with one wheel is obviously relative to what's happening to the other wheel, hence giving it the kind of anti-roll effect rather than it just being like bolted down. You're getting that benefit, making the car more drivable. So I thought that was quite interesting. So, and here where your anti-roll bar is bolted down, so if you have an issue and you need anti-roll bar bushes changing, this is what they're changing, these rubber bushes. And there's like a rubber bushing, and then a like a folded metal part over there, and then that's bolted down either side, so it can move a little bit. There's obviously some movement in the rubber, but yeah, if it moves too much and starts knocking, then that's anti-roll bar bushes. Zoes don't tend to suffer from them, but other cars certainly can. And I've put a light in here, so normally on this bracket, the orange wire to the high voltage battery, and then the comms low voltage command wire will be here. And if we look down here, you can just see, is it better through there? Yeah, maybe we'll go right down, hold on. Yeah, there we are. So that's the high voltage battery, front end of the battery, and then where the cables go. Put a light under there so we can see. Yeah, and then those cables are normally connected onto that plate, and then come up and onto this plate, and then wiggle up and on, sort of come up and onto the motor stack. But this is obviously all out. So yeah, I've just swapped that steering rack over. It had a real knocking noise over the bumps, but yeah, lower arms were done, drop links were done, which can also cause it, but drop links tends to be not quite such a loud knock. Yeah, quite a fun job. I've never done a steering rack on a Zoe before, but it obviously makes it a lot easier when you've got it in this state, that nothing's in there. So yeah, hope that's interesting. I always think it's quite cool when you don't normally get to see a car like this. You obviously wouldn't normally be able to see these parts, they'd be all buried. But there we are. So yeah, hopefully that'll solve the knocking noise. There's not a whole lot else that can be causing it. So, but yeah, no, when you sort of wiggled the wheels side to side, it really caused that audible sort of knocking. I've tried to wiggle the old rack, but you need that force of having a wheel and the leverage to give it that noise. But yeah, it's kind of like a bit of play. So normally where this where this should always, one in one out all move, yeah, it was really having quite a nasty loud knock, and you could really feel it through the steering wheel. So yeah, hopefully that will sort that out. So I just need to get this all bolted up. I need to look up torque settings, get this all torqued up, and then I can carry on rebuilding the stack. So yeah, I've started getting the first bits back together. Just try not to fall over anything. So I've got the reduction gear back on there. It's quite a bit of aluminium corrosion on it, so just cleaning up all the surfaces so it all mates sort of bang on. Yeah, and then I've got the control box over there, so that's got to be remounted. Got all these wires to do up onto the motor controller, so like motor wires. Get that stack rebuilt, air conditioning compressor goes on there. And once that's fully built, I can get that back in the car. So I hope that's interesting. Anything else you want to see while it's in this state, yeah, just let me know. But yeah, a little bit of a project, couple more things to do. All right, catch you later. Okay, so time to start rebuilding. So in the last video we got this motor rebuilt with new bearings, and that's sounding pretty good. Well, doesn't make any noise at all, which is perfect. It sounded pretty horrendous before. I've still got the position sensor and the new like ring that goes in the middle to go on there. So yeah, they need to be refitted on there, and also the brushes and the plastic sort of clip that goes around the wires to all be refitted. Then the motor will be totally done, and then we've got to rebuild the stack. So we've got the what's called the PEC there, which is like the charging filter, so pretty much onboard charger, motor controller, DC-DC converter, yeah, lots of sort of power electronics basically all fit onto there. There's the reduction gear, which is over there, that needs to be refitted on this side of the motor. And also there was a little bit of an oil leak when I did the lower arms on this vehicle, just from the reduction gear, so I've got that's an oil seal for it. And then when that's built, then there's the wiring loom that goes all around it, and then that'll be ready to put back in. Just started looking at the steering rack as well, so yeah, just started unbolting that. I just need to refer to the procedure because it's not quite as straightforward as I thought it was, but going to have a look at that. I need to look up the torque settings anyway, but yeah, time to start getting this back together, so we're going the right way. All right, let's do it. Okay, so we've got the reduction gear on. So in here is the motor output shaft, and that's got the sensor, rotor position sensor. So that's all refitted. Reduction gear is on. I've got to do the other end to get the control box there, the PEC on, but I've also got the brushes refitted, brush box on, and the cover on those wires there, so that's good. So that's ready to put that on. At the minute, I'm just looking at, so this reduction gear, it's got seals here, and this one was leaking a bit. When I did the lower arms, we talked about earlier, as that, you can see that the kind of wheel drops down, the strut, the shock absorber extends, and as the drive shaft kind of moved like that, this was leaking a bit of oil, and I was a bit concerned about that, and the seal was like 12 quid or something. So I thought I'll get one of those. So I've sort of yanked the old one out, and it's really tight fitting. I don't know if it's because it's kind of cool ambient temperature that this is all kind of contracted. I tried heating this up with a heat gun, still really tight. I've actually put the seal in the freezer because the missus is out shopping with the kids, which is cool. So yeah, I'm hoping if I heat that with a heat gun and then I've got the seal in the freezer, that it'll actually go in sort of easier, but it's a real snug fit. So yeah, that's a little bit of a challenge at the minute. Not had to do that in the past, so that's a new experience. So we're getting there with that. I always think this is quite fascinating, really. So the mounting points for holding the stack in. So if we go into the engine bay, so there's three holes there, 3 bolts go in there, nice long bolts. And they bolt into the top of the PEC, which is over here. We go over here, so you can see there's 3 bolts there. So nice and stable at that end. The other end, the sort of reduction gear end, there's a hole here, and then there's a big kind of round thing, like the world's biggest washer and a nut, and that bolts on to this thread, which is on the reduction gear. I was just looking at it as I was sort of musing what to do about that seal. You can see here that this part of the thread's unused, and the bolt is basically on. It's kind of blurry, isn't it? If I can get it to focus. There we go. Yeah, on those like 4 or 5 turns of thread. I mean, it obviously works. I've never seen one fall out, but it's just amazing, really, to hold this end of it on that mounting. I don't really know why it's done like that, to be honest. There's another mount there. No, it's all out of focus because I made it focus close. Like a kind of dog bone one there. That's an anti-vibration mount, really, to stop that twisting torque. So that's not really holding it up. It's just holding it in place, kind of thing, stopping it from moving. But yeah, I'm always fascinated by this end. It's just like those, yeah, just those 4 or 5 turns. Oh, there we go. Yeah, I'm always kind of fascinated by that. But yeah, it obviously works. Never seen one fall out. Just yeah, make sure we took that one up properly. All right, cool. So yeah, in a minute, I'm going to get that seal done and get that box on, and then we'll have a stack rebuilt. Yeah, ready to go back in the car. All right, cool. Catch you in a bit. Okay, next step is complete. So we've got this control box back on. So that's all bolted on. So it's got a bolt sort of down here on either side, little 13mm there on that stud, and it also bolts sort of onto the motor there, and then there's a bracket sort of to the side of the air conditioning compressor, that an L-shaped bracket bolts onto the motor, bolts onto this side of that PEC, that big box, and then there's a little bracket there that kind of holds a cable, but yeah, just steadies that as well. So that is all bolted on. I've also done the this seal here, which was an absolute nightmare, to be honest. They're really tight, like any sort of gearbox seal, I suppose, have to be to prevent leaks, but yeah, a bit of a nightmare to get in. If you need a seal there, get someone else to do it. Take it to a garage, you've got the correct kit with the cups and all that. To be honest, I won't do those myself again. That was an absolute nightmare. Trying to get it in, you got to tap it really hard, but you don't want to damage it, and it's kind of rubber covered, so real nightmare. But that is in. I'm just hoping it won't leak, but we will see. Yeah, so air conditioning compressor on. So next is this wiring loom. So this is the motor stack wiring loom. So these are all the connector points around here. So these 2 connector points here, that one is the one from the rotor position sensor. And also oddly does the control for the fan, that big black round motor cooling fan that sits up there, and then it's ducted down into there and cools the motor. I think that is part of that loom because it's controlled by the motor controller. So yeah, the motor controller obviously needs to know the rotor position, so that little mini loom is going to the motor controller in there via that plug, and the motor controller is also controlling the motor cooling fan, obviously, because if it needs cooling. So it's all kind of related, that's why that makes sense. But yeah, so this harness connects to these points on here, connects to the that's the gear position sensor. So in the Zoe, when you move the gear lever, the kind of reverse neutral drive lever, it connects to that pin there, that one that's shinier, and moves that, and then that moves that sensor. It does the parking lock as well that's inside that reduction gear. Yeah, and that loom has got like the comms and the power for the air conditioning compressor. So yeah, got to get this all back on. It also connects onto the main ECU, and got relay box, connects to what's called the power and switching unit, something like that, which is this, the one that's 12-volt fuse box, but this one under here, that box. So you got to turn that upside down, and it gets power from in here as well. So yeah, that's got to be refitted onto this stack. So I'll get that around there next, and then we'll get that ready to go back in, and then we'll put it in and see what happens. Right, we're getting somewhere. Okay, cool. So now we've got the stack built, wiring looms back on, water pumps back on, and this is basically ready to get back in the car, get it wired up, and see what happens. So yeah, if you want a bit of a guide to what we've got here, so yeah, we said that one's the one from the rotor position sensor. This one's the one that connects all the sort of control boxes to the main car, so sort of rectifier, DC-DC converter, stuff like that. That's where the charging comms goes from the charging socket. That's the DC-DC output, so that's the main 12-volt, sort of like 14-volt supply. Up here, these are for the motor cooling fans. That's the control, the comms, and that's the power for it, and there's a relay box for it there. And then along here, this is the radiator, power and control. Yes, that's the gear selector switch. That's the relay for the radiator. Water pumps around there. These are earth points, and this is for the 12-volt test box, which is that aluminium fin thing there. So when the car starts, you've got a Zoe up to 2019. If it's dark, you might notice, if you have a look at the interior light, as you open the door and sort of unlock the car, the interior light will come on, and then it will dim for a second, like almost flicker. And what that is this is called the pulse box, or 12-volt test box. And this box puts a split-second load on the 12-volt battery to give it a test. And if it's in a poor health, then you get that check electric on the dash. But yeah, that's what that does. And that's that blue plug for that. So then we've got these wires. So these, see this funny shaped rubber thing fits into there. So that's the switching and control unit or something, I can't remember. But yeah, those plugs will go into there, particularly like that single wire one. Nice bit of design there. This is the power that comes from that red lidded unit. That's 12-volt supply. It's kind of 12-volt onto the car from the DC-DC converter unit onto the battery, and then 12-volt little mini fuse box there. And then we've got some bigger fuses, maxi fuses, and supply for that fuse box. So those two fuses there, which you can see there, fit into there. That's part of that. And then we've got the main ECU, so that one fits into there. And then that one is the 12-volt battery current sensor, which is on the negative lead there. There you go. I don't know what I'm doing, just off the top of my head. And then obviously these two are the main battery power, big orange 400-volt cable, and then that's the comms for the battery sort of control. Yeah, and they're the two cable holding bits that fit onto that tray there, and then they feed through there. So yes, that's how it goes back. That's what everything is. Hope that's interesting. And yeah, next step is to get that back in, but we are ready to go. All right, catch you later. Okay, so we got this stack back in the Zoe. So next thing is to get the minimum connected up so we can test it, see if it starts, spins, see what it sounds like, and also charge it as well, just to make sure everything is working and see what it sounds like. Basically make sure we've got no major issues. So I've literally just bolted that in. Actually, I was saying in the last video that this one's not held in by that much. Actually, that sort of dull bit on the top is what sticks out of the nut. Fortunately, that nut is quite deep, so there's quite a bit of thread there. But yeah, it still amazes me that it's only got one bolt on it. But yeah, that's how it is. So yeah, so I've got all these connection points I was talking about in the last video to put back on, high voltage battery. Yeah, and just get it to the point where it's happy to start. So 12-volt battery will need to be on, so we've got power, and obviously do high voltage sort of activation on it as well. And yeah, just make sure it spins and it's happy and go from there. So, but at least we're going forwards with this now, and I'm going to crack on and catch you later. All right, cheers. Okay, so this is all now wired up. So battery's connected underneath, all the necessary points are kind of connected, and we should have the minimum to start this and get it to spin. I've done the sort of high voltage activation, so that is all fine, and we'll just see what we've got. So, right, let's just wake it up. And right, battery charging impossible. Well, we haven't got a charging socket, so that's kind of to be expected. Right, let's make sure it starts. I've got no insert key card. That's because I left it on the roof. One moment. Right, let's put this in. So we've got the we haven't got the rear engine mount on, but that usually shouldn't make a difference. That goes to ready, so that's good. We've got no drive shaft, so I have to be a little bit careful, but we can put it in drive and just let it spin. Sounds a little bit notchy. Okay. Because I've not got the rear mount in, it was bumping a little bit as well. Yeah, that sounded a little bit, that was a little bit kind of the reduction gear cogs. It normally just whirring kind of noise, but yeah, that sounds a little bit like the cogs in the reduction gear are not too good. So we debated when we first got this one in whether the noise was just the motor. I mean, the motor was bad, but that doesn't sound perfect. It did bump a little bit. I think I need to just steady that stack a little bit more, because it's not got the rear engine mount on. So there's a mounting there, that one hanging down, that fits on that bracket that's down there. But I might just yeah, wedge that and just double check. Okay, cool. Right, I am just going to yeah, I'm just going to support the stack a little bit more so we can do a further test. I'll be back momentarily. Right, let's give this another go. Hopefully we should be able to leave this spinning now. I've just supported the stack a little bit at the back. Right, so we're still in ready mode, so we should be able to just leave this spinning now. Just going to tap the accelerator gently, get that spinning. Right. Spinning. It's only just moving a tiny bit. I want it to move a little bit more. Come on. Spin. There we go. Oh yeah. I guess you can hear that. Yeah, that's too noisy. Okay. Right, let's turn that off. We have to do this quite carefully because we've not got drive shafts. We have to stop the motor because of the parking lock. So if we just pop it in neutral and just let it spin down. Basically, it's got a parking lock and it's a physical pin in the cog inside the reduction gear. I'll just shut the door so it doesn't beep. So yeah, if I just try and shove it back in park, then it'll just grind the parking lock, basically. So yeah, so I have to let it spin down before I can put it back into park or just turn it off. Okay, so it sounds like the reduction gear is noisy as well. That's slightly annoying, but
to be fair, when we first started this, I did say the noise was not quite the normal motor noise. There was a slightly different kind of whine to it, and I wonder whether that is, there we go, we can put that back in park now. I wonder whether that is the reduction gear. Okay, right. I haven't actually got a reduction gear for one of these. I've got a later one, a ZE40 onwards, but it doesn't have a parking lock. Okay, I need to have a bit of a think about this. I might get the reduction gear off and take it apart and have a look inside. We definitely know the motor's not noisy, don't we? Because we spun it, and that's definitely quiet. I know that it's got no oil in the reduction gear, but it does sound really, it just kind of sounds loose, doesn't it? Just a really sort of notchy, coggy noise. Okay, right. I will do some thinking. I might get that reduction gear off, and I'll catch you in a bit. Interesting. Okay, so I'm just preparing to get this reduction gear off, because we need to investigate this noise. I do remember when I took the gear oil out, it was a little bit dark, but yeah, you can never kind of know until you try. And obviously the motor was making a lot of noise, so the gear oil had been there a while, but we now know the reduction gear sounds noisy as well. So yeah, this is the reduction gear. It's got the engine mounting on it there. I don't really want to have to take the whole stack out, and then it's not that easy to manoeuvre and get that off. But yeah, so I've got a lift there. That's a 450 kilo lift. This all weighs about 150 kilos, something like that, so that's okay. So yeah, I've got to basically get that engine mounting there. It's on the end of the gearbox. It's got 2 bolts on the end and 1 at the top. Get that off. I've got all the wires and connectors and things off it. 12-volt batteries back off. So yeah, hopefully I can get that engine mounting off without too much difficulty. I can lower it a bit and then hopefully get that pin out, wiggle that off, so that shouldn't be too much of a problem. And then this reduction gear is reasonably heavy, probably about 15 to 20 kilos, something like that. But it's got to come off nice and straight, basically. So yeah, we will get that off and have a look inside, I think. So the Zoe's up to 2019 have a parking lock. So when you move the gear selector inside, there's a cable and a pin here. It's this cable here, and this end pops onto this shiny pin, physically moves that, and then there's a sensor to detect the position. But there's also a physical parking lock inside. Now I've got reduction gears from 2020 onwards, ZE40 ones, but they don't have this sensor and they don't have the parking lock. I can transfer this sensor, but the parking lock is inside here. So yeah, I can either order a reduction gear for an earlier car, which I could do, or I might try and convert a later one and put the parking lock inside. But it will depend on, once I open this up and have a look inside, whether we think we can open up a ZE40 one and move the parking lock over, or if something's changed inside. But yeah, well, let's have a look. Let's get this reduction gear off first and see what's going on. Right, cool. Right, so got that off. A little bit awkward, but not too bad. It's always fun taking off something you just put on, but you've got to test these things to work it out. But I'm kind of learning to trust my instincts, because the sound was a bit different. If you've heard a Zoe motor with bad bearings, it's a sort of hollow rumble noise, and this car, as well as that hollow rumble, had that high-pitched noise. So, and the reduction gear oil was dark as well. So right, so what we need to do is get this apart and have a look inside. I think mainly just to see whether we can swap this over and yeah, make a good one out of a ZE40, as I was kind of explaining. So right, let's crack this open. It's going to be interesting. I have had one open before, not to fix it, just for kind of interest really, so I roughly know how they come apart. But yeah, trying to keep all the bits in the right place is a challenge. But obviously in this one we don't have to. We just have to get the parking lock out and work out how to take another one apart. So this one we can kind of take apart anyhow, as long as the parking lock's still there. You know, obviously don't want to damage that, but that's going to be easy. Yeah, it doesn't matter if cogs fall out and things like that. We just work out how to take apart the next one, a ZE40 one, and see if we can put the parking lock in it. Because I've got 2 or 3 ZE40 ones, just from motors I've bought and used. So right, let's do it. Okay, so I've got everything stripped off. I've got the gear sensor off there. There's a bracket there, this thing that holds the gear selector cable. Yeah, so I'm just going to undo all these Torx bolts,
and take this off carefully. So this is a reduction gear 10-to-1 and a differential as well. So there's a diff here and then the drive shafts come out either side. So there's quite a lot in here. Yeah, so it was a bit interesting last time I opened one up, but yeah, at least we'll have an idea whether we can make use of this parking lock or not. I don't actually know whether there's even the gap for the parking lock to fit it into the ZE40 so but it'd be interesting to see if we can get it out anyway, or whether we just need to just order another one. But yeah, we'll see if we can make what we need out of what we've got. All right, cool. So just trying to get this reduction gear apart. It's interesting because, you know, sort of all the bolts around the edge going from the top, so presumably it's manufactured this way and then the lid's put on. There's a bit of resistance trying to pull the lid up, but there's this plug here which covers up this point here just below the breather, and taking that off there's a circlip in there, you can see. So I'm like, okay, so maybe we have to release that circlip and lift the lid. So I'm going to give that a go, yeah, and just see how this goes. So yeah, all right, wish me luck. Catch you in a mo. Okay, so now we're getting somewhere. This is quite cool. Right, so we've got the two halves open. Releasing that circlip just allowed this set of cogs just to move a little bit, and then just allowed everything to move enough just to get it apart. So what have we got here? So this is the parking lock, which I'm hoping to transfer to a ZE40 gearbox, but we'll see. Reduction gear. I don't even know if it's machined to fit it, but we'll find out. It's certainly still got the hole here where the sort of locking pin goes through, or the actuator to do the locking pin. So yeah, so the motor turns, the motor splines go in here and turn this one, and this is where the locking pin. So there's, if we look on here, see this sort of pops out. I've intentionally made it not in park, just so it's going to be easier to take apart and put back together. So I'm not going to pop that out because I don't know how easy it is to get back in again without the lever on the top to turn it. I don't want to be stuck with it out. But yeah, that little not basically sticking out bit pops out and goes in here. So yeah, and then we can see down here, that's a little bit blurry, but there's a gear there. That one turns this big one. The big one turns the smaller one under there, and then that turns the really big one, and then in the middle of here is the diff. So yeah, that's got the, if you're familiar with how a diff works, yeah, so those two can turn sort of independently of each other, and turn yeah, sort of as they need to, really. So one can have more power than another, but quite cool. So but obviously we're trying to work out here what is actually noisy, what's gone wrong. So there's a magnet here. This is where you don't get big chunks coming out of a Zoe reduction gear, because it's got a magnet. So it's got no chunks on it. But, so there's no sort of indication of wear on there. But if we look, and you can see here the oil was obviously very dark, that was in here before. So, and it is certainly noisier. So what can that tell us? Well, nothing's been caught on the magnet. The case is aluminium, and the cogs are obviously steel or some kind of hardened metallic material. So I'm kind of thinking that it's probably worn the case a little bit, and everything's moving a bit too much, and that's what's causing kind of the cogs to be a bit further away from each other than they should be. That's one potential. But yeah, I thought it was quite fascinating, really. So yeah, I don't know whether I can make what I need out of a ZE40 one and this one. I've got gasket sealant, so that's fine. I think I need to take a ZE40 one apart and find out what's going on. So as long as it's still got this part, I mean, they could have redesigned this, or they could have been lazy and just left that as it is, taken that lock out. But the question is, did they even bother machining the case, because they wouldn't need the holes? So yeah, possibly not. I don't know. Am I going to be able to look down it and see? No, I don't think I'm, because on the ZE40 there's, on this part there's just a cover panel here, but I don't think I'm going to be able to look inside there, am I, and see whether it's machined. I don't know. We can give it a go, possibly, maybe with my little boroscope thing. Yeah, we'll give it a go. Right, I need to go and grab a ZE40 gearbox and do some surgery on that and see what's happening. All right, cool. I'll catch you in a bit. It was all good fun. All right, cheers. Just noticed something else actually when I stopped recording. So I was looking at this thinking, oh, the machining's not very good, but I actually wonder whether it's cracking a little bit. Can you see around there? doesn't look too good, does it? It does look like it's sort of suffering from fatigue, doesn't it? And there's a lot of, you know, there's a bearing spinning inside there, and there's obviously a weak point because it's thinner there. Similarly, sort of over here, yeah, it doesn't look that good, does it? Sort of more over there, yeah, it's not looking that pretty. It does look like it's cracked there, doesn't it? Try and get that in the light. And whenever I move, it gets more in the, my head torch gets closer, but I cause a shadow. Oh yeah, you can see there. Yeah, that doesn't look too good, does it? Similarly, sort of there. I don't know if that's just where it's been made, but it doesn't look good, does it? Okay. Well, we can see what the other one looks like, and yeah, go from there. But yeah, interesting stuff. Really noticeable up there, isn't it? Yeah, not very pretty. Right, cool. I'll catch you in a bit.
Okay, so I've just grabbed the ZE40 reduction gear out of my storage container. So I basically haven't got any ZE40 ones at the moment, just ZE50s. I've actually sold 2 ZE40 ones recently. I can get another one, but I've got 2 of these, so if I can use this, I will do. So, it looks visually the same. There's sort of space for the parking lock in there. You can see it's just got a blanking plate, where the ZE40 one has got this sensor on. And then that's the bit that actually sort of actuates the parking lock inside. So yeah, let's see if we can convert this. Basically going to pop this off, see if we can see inside. Might need to use the boroscope to see if it's like machined for these tapped, is it, for these bolts, and then if so, whether it's also got those notches on there, and see if we can fit the parking lock. So it's all good fun. Right, catch you in a bit. So we can see a little bit more inside this reduction gear, and I've taken the parking lock off, so we're looking down, so there's a larger sort of hole with nothing in it, and then this is where the parking lock, here and here, is where they bolt onto. So we're trying to look for this point here, the second hole down. We're trying to shine this in here and look in there as well. But if we can see, slight challenge, we've got to look that way. Ah, you can see there. Hard to get it to focus and get the light. There is a hole there. If I do that, get that to focus. Come on. Oh yeah, there you go. You can see the hole, and then you can see the larger one above it. Not getting it to focus too much, but so it's not got. There's obviously a hardened collar on that, and then it's threaded further in. I think it's unlikely to be threaded that. But yeah, I will get the boroscope just to check, because if it is, it's a goer, but it's probably unlikely. We'd also have to move that steel collar. No, it won't focus because I've just got to focus on something else. Move that steel collar, which might be a bit of a challenge. But yeah, interesting anyway. If I was unscrupulous, I wouldn't worry about the parking lock and I'd just stick the sensor on the top, but that's not the kind of thing I do. So yeah, I'll double check with the boroscope, but yeah, it's missing that collar anyway. I strongly suspect it's not tapped, but yeah, interesting stuff. Yeah, it's definitely that one. Cool, right. Well, I will double check that with the boroscope, but yeah, I think I'll have to buy another reduction gear, which is slightly annoying. Really fascinating that that one's noisy, but yet there's no sort of real visible wear on it. But I think it's just a little bit looser than it used to be, and I'm not really happy with that amount of noise. It obviously has had quite dark coloured oil, which is a bit of a sign. But yeah, all right, cool. I will catch you later. Cheers. Okay, so let's fix this reduction gear problem. So yeah, in the last video we had a look inside this reduction gear, trying to work out sort of what's wrong with it, looking in the case. There's a really interesting discussion in the comments actually about the casting, and where there's these kind of cracks. The general view was that that could be normal, and interestingly that kind of potentially coincides with where the lines are there, so that may be normal. However, this reduction kit is obviously making some noise. So I was having a little bit of fun and games getting my boroscope to work out whether we can put the parking lock into this reduction gear. I managed to get it to work, and we were trying to work out basically whether these holes are tapped, because this is a ZE40 gearbox reduction gear, and it has a parking lock which jams up these. Where is it? Oh, I think I've taken it. Oh, it's over there.
those ones, the parking lock pops in there to physically stop the gear from moving, and it's this lock here, and the pin there pops out. Some boroscope. So that pin pops down and literally jams into there. And this gearbox is from a ZE40 reduction gear, and it doesn't have a parking lock. It has an electronic parking brake on the rear calipers. So yeah, it was a kind of a case of, could we convert this box to be used on the ZE40? Now, if you put it on, it would work, but it's just that the car wouldn't have a parking brake. It just have the manual handbrake. So I want to put this back to as it would be from the factory, repair it properly. I managed to get the boroscope to work since I did the last video, and looking sort of in and down and into those holes, it is actually tapped. So you could potentially fit it. It's missing the collar. So there's like a steel collar on those to give it something a bit harder to hold it from sort of movement. So that would have to be moved. Obviously you have to open this up. There's always a risk when you open something that it's not going to be quite right. It obviously has to be resealed. And basically the ZE40 box one was available. So I ordered it, and it is there. So we now have a replacement reduction gear, which is cool. I do wonder whether these, so I've got 2 of these ZE40 boxes, but they may well be required from other cars in the future, so it will be a bit short-sighted to kind of make it work when another one's available, basically for sort of a reasonable price. So yeah, that is the next job, to get that reduction gear fitted onto there, and then spin it up again and just check the noise, basically, because it was making too much noise. Interestingly, someone was commenting about the teeth on these gears. So I put the boroscope when I was in here, because this is a real low mileage reduction gear, and it's the same design as that, literally the same inside, just with the parking lock on that one. So I had a look at the teeth on here, so I've got a picture of that as well. So if you look at these teeth, I'll just turn my head touch off. You can see that it's nice and sharp. It goes to a nice corner, okay, and yeah, it all looks good. Obviously really minimal wear on that, so that's nice. And I was looking down onto this cog, and if we look on this one, oh, turn the torch back on, we can see that there's quite a bit of wear there. There's actually sort of corner wear there, and if I can get that to focus, so you can see there where it's sort of pushed the metal over. So you can kind of see there's wear on there that's not on the low mileage one. So that's quite interesting, and that exists on all of the cogs that I looked at in this box. So if we look at the big one, you can see that wear on the corner there. Let's see if we can get a slightly better shot of it. You can see that corner. It seems to have a bit of a corner that's not on the other one, but also that kind of additional wear there. Yeah, it doesn't look great, does it? So yeah, maybe these cogs are all just a little bit worn and a little bit noisy, and that's too much noise for me. Yeah, because I want this vehicle to be reliable and work for the new owner. So yeah, fortunately that box was available, and we're going to put that on and see what happens. So yeah, any other thoughts or other things you want to look at, let me know. It was interesting opening this up. It's good to know how they work, and if that box isn't available, then I would open this up. I'd obviously have to work out how to try and remove those collars, but yeah, if that was the only option, we'd have to do it. But it's always better just to have a simple solution, less risk of issues. And obviously we've been doing the motor bearings on this, so it's a reasonably complex job, and there's always a potential if you open up a unit that you cause a problem. So yeah, I'll get that box on, and then we'll see what it sounds like. Right, catch you in a bit. Okay, so we're getting somewhere now. So we've got the, just move this out of the way. We've got the new reduction gear on there. So when I say new, it's not new. It's new to this car. It's not brand new. I've also put the drive shafts in. So on a Zoe, it's got a short drive shaft here from the reduction gear, because the reduction gear is on this side. And then the one over the other side is a longer one, if we can see. Yeah, so you can see it goes all the way down there. So then it goes all the way to the reduction gear over the other side, and then there's kind of like a bracket there with a bearing in it to sort of hold it still. So yeah, I've put those in place just so we can give it a bit of an easier test, and you can spin it a bit more and it's easier to stop it. I have also put the rear engine mount on. Well, it's not really a mount, it's sort of stabilising bar. I kept talking about it and didn't actually show it, but yeah, there's a sort of dog bone one there that fits onto, oh, there you are, fits onto a bracket that's bolted on the back of the motor, and you have to take that off because that's in the way of the bolts that hold on the reduction gear, kind of like these. Like there's one there. Let's move this back. Yeah, there's one there and sort of one here. There's bolts all the way around, and one of those is in the way of the that bracket's in the way of that bolt. But that's all on, so we can give it a proper test. I've also, as you can see, put the charging socket on, so we can give it a proper test, make sure it spins, that it sounds better, and also that it charges. So if we just hop inside, so our battery charging impossible has gone away, which is good, because that was we were presuming caused by the lack of the socket. That's the brake booster, that buzzing noise. So if we start the car, a little bit fuzzy, but get the gist. And that started spinning. Go and have a listen. Traction control may kick in, but yeah, that's sounding a lot better. Sounds a lot better. So you can see it sort of spins the wheels forwards and backwards, and that's kind of like a traction thing. So it's trying to sort of see if the car's going to roll, and that's just how the Zoes do it. It kind of goes forward and backwards. Yeah, that sounds a lot better. You can still hear a reduction gear noise, but you kind of expect that. But that grindy, that sort of loud grindy noise has gone away. So fantastic. Let's just stop that. I put the drive shafts in because it's a lot easier to stop the car. Just having more things in, making it more stable. That's kind of just slightly easier. So I'm just going to brake gently. Oh, good for cleaning up the discs. And then we can put that back into park and turn it off. Right, okay, cool. So replacement reduction gear seems to have done the job. That's now nowhere near as noisy. To be honest, if you remember, if you've sort of watched this little video series from the start, the splines, the output shaft splines on the motor did have a little bit of wear on, and there will obviously be, or is likely to be, similar wear inside the motor, or inside the reduction gear, sorry. Oh, we can actually see. So that will be, where will that be? Ah, that'll be on here. So this is where the motor goes into. There'll be similar wear in here. You can actually see they're slightly off center, aren't they? Sorry, this light's not perfect because I'm trying to get the camera in there, and then the light. Oh yeah, you can see where it's folded over, sort of over here. You can see where there's been a bit of wear and it's pushed it over. It's like kind of a similar effect to on this big gear where I can literally feel a lip there where it's sort of heated and worn and pushed a little lip over. And this is a real hardened metal. These are surprisingly heavy. But yeah, so it's sort of no bad thing to have a new reduction gear on, just for the sort of longevity and yeah, of the vehicle, just to keep it working for a long period. So yes, we've got no errors now. It starts and spins and sounds good, does what it should do. So let's just give it a charging test. So I've got my type 2, this is just on a 3-pin cable, and I'll try and do this one-handed. Let's just plug that in. Now obviously we've got no cooling at the minute, so this is going to be a brief test, but we just want to see that this charges. Oh, there was a click then. We just want to see this charges. Yeah, and it started winding. Cool. So that is charging. It'll show a long time. That's showing 13, nearly 14 hours, but that's because this is a 41 kilowatt hour car, so it needs to take on about 20 kilowatt hours, and we're on a granny cable and it's balancing, so it's got, like, you know, quite a bit of charging to do. But yeah, I'm going to turn it off because I've got no cooling. I mean, it's like 0 degrees today, so nothing's going to overheat, but yeah, just got to pull this out before it starts charging again. Sorry, one-handed. So yeah, cool. So that is starting, spinning the motor. It sounds okay, it's charging, and I think that is good. Yeah, I think that's good. So we're going the right direction. Motor isn't making any noise at all, which is perfect. Really difficult when you do a major job like a motor rebuild with bearings to know the long-term reliability. I mean, obviously you can't test that when it's like this, It's got to be back together on the road, do a decent amount of miles. I have rebuilt a few motors, so I'm kind of reasonably confident with that, but you never exactly know, you know, what it's going to be like, how you've handled the bearings, how you've put the bearings on, all that kind of stuff. Yeah, so far the few I've done have been good. I sort of take my time. I generally don't do something unless I'm happy with it, basically, especially something like motor bearings where it takes about 10 hours to change a motor. You know, you don't want to go ahead if you're not happy at any point. So but yeah, hope that's interesting. I have to say, there's really interesting discussions in the comments, really interesting to see how people are engaging. To be honest, I kind of thought doing this was interesting. I didn't know if anyone else would be interested, but I've been really amazed by the sort of engagement. People are interested, and yeah, it's just really nice to see. I try and sort of reply to comments and stuff. But yeah, do just sort of drop any questions. If you haven't subscribed, that would be fantastic. Yeah, questions or other comments or yeah, that kind of stuff. So I think this is pretty good to continue with the rebuild. So what else have we got to do? Well, there's one or two things. See, that charging socket needs to start off again now. That was just for testing purposes. We can kind of look around and see what's required. So we've got like a subframe there. We've got the radiator pack there under that rag. Arch liners. We've got the top slam panel that runs across the top. What else have we got? There's a crash panel over there. That's got to go back on. We've got arch liners, under trays. Don't worry about all that stuff. That's just some parts. So yeah, a lot of rebuilding. Probably 3 hours or something like that of rebuilding. And yeah, then basically get this on the road and do some more testing. The MOT's actually expired, so we'll need an MOT. So yeah, brief test down to the MOT centre, and if that looks okay, then yeah, get it MOT'd. So yeah, hope that's interesting, and I'll catch you later. Cheers. Okay, rebuild time. So in the last video, we got the reduction gear swapped for a replacement one, and got that sounding a lot better, and tested the charging as well. So we're kind of happy this car is fixed as far as we can tell. Obviously can't do too much testing when it's like this, but it's all looking pretty good. So it's time to get it back together so we can do a road test, get an MOT, and then see how we go. So what's the next step? So the next thing is the subframe, which is that one front subframe, which fits under here. I think it goes across and then goes back there. And also there's that aircon pipe going over there, comes over and onto the compressor, and there's some brackets. Once you get the subframe in, there's like brackets that go down there. Yeah, and that's sort of first steps of the rebuild. Also around this 12-volt battery, so fuse covers, tidy all this up. So when you take the stack out, you have to take this off, and there's a load of connectors under here. So get this all properly refitted, the lid is there, get that put on. The battery train is put in on properly. There's connectors on there that go on the side. This fits on the side. So all that area around there's an earth strap, another earth strap at the back as well. So that's sort of next steps. And once that's on, once that subframe is on, then it's radiator pack. That's over there. So that can all fit back on, and then the rest of the air conditioning pipes, coolant pipes, water pump, kind of connections to the water pump, and get that all sort of starting to be rebuilt. Basically they're the next steps, so I'll get those done and I'll catch you in a bit. All right, cool. Okay, so we've got those bits on, subframes on, and that's all torqued up, and those brackets around the side are on, and I've also sort of refitted these bolts in here, and torqued up those, and the hub nut on the end of the drive shaft. So yeah, and all these bits around the 12-volt battery, so that's cool. So next steps is the radiator pack, which is over there. So that goes on, and then that's got aircon pipes. So it's got one there that goes into one side, and then over there, just in the dark, the other side goes in there. It's also got its water pipe connections, so one onto the water pump, and then one goes onto that one there, onto the PEC. It's also got power as well, and that stuff is all here, all of that stuff for the radiator. So there's a relay, power and control there. And then with that on, the next things are the slam panel there. That's the washer bottle as well, which just sits on there. and then there's a crash bar as well that fits on. That's the next step. So just all sort of mechanical and pipes, and nothing too complicated, but they need to go back on. But yeah, we're getting parts back on, so this is cool. And then following those is going to be the fun and games with that wiring loom that fits on the front of the sort of slam panel and radiator, and then that connects across to various locations, but we'll get to that in a bit. So I'll get those bits done and catch you later. Cheers. Okay, so we're looking a bit different now. So we've obviously got the radiator pack on, washer bottle, we've got the crash bar and that slam panel on, and there's the bonnet release catch from inside, and yeah, that's all gone fine. Put some coolant in it, just letting that sort of bubble a little bit, so that's all in there. So yeah, just started it, still no errors and all good, so that's cool. So the next step is this wiring loom, the one that was hung over the mirror, and this fits onto various places. So it clips onto the horn, which is there, and I need to clip that on and then put that in the correct place. It also, there's a connector onto the bonnet catch there, so it knows whether the bonnet is open or closed. And then this wiring loom, so it clips on the front of there, and then it clips on here. It's got the headlight connectors for that side on it. Weirdly, the headlight connectors for the other side are not on this loom. Just a slight quirk of sort of how that's done. So I'm just going to move without tripping over. And then, so let's just move this up so we can see what we've got. So then there are connectors for this, which is one of the air conditioning sensors. There's the washer bottle pump. There's another air conditioning sensor. So that you can see there's a temperature sensor there connected to the pipe, and that's on one of them. And there's another sensor there. There's a couple of AC valves up there, and also the connector on the brake fluid reservoir. Yeah, and I think that's about all of those. Yeah, and then just the headlight ones. Yeah, 2 headlight connectors. So yeah, that's what I've got to do next. And then following that is the charging socket. So that goes on next, and that bolts on here and there, those grey ones. Yeah, then following that on the front is the air deflector. So there's a big sort of oval thing which is just over there behind the jack, and that fits just on here, basically just to duct the air in, because the gap on the bumper is a full oval, whereas this radiator is offset basically, so there's like a gap there. So yeah, that fits on there. Following that, I've got the cabling to the battery. There are some, I don't know if we're really going to be able to see, but oh yeah, maybe. Oh yeah, you can see that black bracket. So the cables are all going above there, so they need moving over. So this is the comms to the battery, and that's got a little clip on it, which we, oh yeah, it's just that clip there should be on that stud. And then that's the high voltage wiring to the battery, and that goes on to that one. And there's also on the back of the stack, there's another a like stud with a nut, and that holds the comms cable as well on there. So yeah, there's also another bracket as well in front of the battery that holds them. So it's just obviously that it goes down and along onto the battery, and there's a couple of different points that just hold that steady. So that's all of the next bits. Then sort of beyond that, it's the final parts of the rebuild really. So we're talking headlights, bumper, under trays, scuttle panel, wipers, that brake fluid reservoir bolts onto the scuttle panel. But yeah, we are really getting there. Oh, arch liners, that goes on with bumper and under trays. But that's basically the final things. There's a slight delay on MOTs. I called my local, I've got a garage just like at the end of the road, just a normal garage, and they sort of do MOTs, but there's a little bit of a delay on those at the moment because they're quite busy, so that's slightly annoying. But I've got a bit of time just to yeah, just drive this short distances. Fortunately, I live down a track off the road, which is really good because I can go sort of like 500 yards down the track, turn around and do 500 yards back again. It just, at least you can just yeah, do 20 miles an hour and see what it sounds like, make sure there's nothing major, check all the sort of any warning lights, fault codes, that kind of thing. But yeah, we are getting there. It needed a tyre, but I've had that done in the meantime. So yeah, I'm going to get these final bits done, and we'll get it back on the road shortly. All right, catch you later. Okay, so we're really getting somewhere now. So this wiring loom is all wiggled around, fits onto the horn there, which is in place, and this is where it wiggles round here, and in the process there's a little tap off to down there, and it's the washer bottle and those ones, and up there. I've not quite popped this one on because I need to move this around to get the scuttle panel in place, but there's the two for the headlight. I think that's the main power and that's the adjuster or something like that. Something like that anyway. Yeah, and also got the charging socket on, so we're really getting somewhere now. So all being well, in the next video we will finish the whole rebuild, get the car on the road in terms of on my lane, and then we'll be able to do a little bit of just low speed and make sure things are okay. We also need to do the tracking as well, because obviously we've replaced the steering rack, so that obviously definitely needs doing, and also find out whether that knocking noise has gone away, because we believe it's a steering rack, but you can never be totally sure. One of these Zoe's front end knocks are a bit notorious for it. But yeah, I'm actually quite pleased with how it's going. I have to say I'm pretty much run out of energy now, so I'm definitely done with this. But yeah, really pleased with the progress, and yeah, we'll see what happens. Slightly depressingly, outside I've actually got 2 more Zoes that need full complete strip downs. One is noisy motor bearings, so we'll be doing this entire job again, just hopefully without the reduction gear fun and games. So I guess we see if that one goes sort of straightforward. And I've got another Zoe outside that I bought, and that one keeps getting a motor fault but doesn't make noise, so it's quite interesting. So I was quite keen to get that one, just to sort of find out what's going on inside the motor, because if it's got noisy bearings, it kind of makes sense that you're getting motor faults, because the sort of movement that's not meant to be there, because it's sort of yeah, bearings obviously extra play when they're worn out and stuff like that, but it's not making any noise, but it's getting the position fault with that rotor position sensor on the output shaft on this end. So I'm quite keen to get on with that one, but yeah, the customer one, the one that's just bearings, is a custom one, so that one's going to need to come first. But yeah, hopefully that's interesting. If you can see, it's really built up at the front there, so there's obviously the bumper left to do. So headlights, bumper, scuttle panel, there's the blower motor on the top, which is not blower motor, motor cooling motor fan that fits there, and yeah, under trays, arch liners and tracking. I think that's it, isn't it? Probably. Cool. So yeah, hope that's been interesting. We're going in the right direction, and I'll continue with this as and when I can, and yeah, catch you later. All right, cheers. Okay, well, it's been an interesting few days, especially if you've got a plastic workshop, as I have. The weather was absolutely horrendous over the weekend. Started off sort of 40-45 mile an hour winds, picking up to 50, just above 50 miles an hour. Incredibly windy. Didn't have much rain where I am, fortunately, but basically this whole workshop, I mean, it's heavy. It weighs about 70 kilos, the workshop itself, and then it comes with ground screws to secure it down, but I'm kind of on gravel, so I've got these like sandbags, so they've got a fair amount, probably, yeah, they're reasonably heavy to lift, sort of 15-ish kilos of sand in each, and I've got 4 of those because it's got like 4 intermediate poles, so there's 6 poles, you know, for the whole thing. So those 4 have got these sandbags on, and same on the other side. You can kind of see behind all the parts and stuff. So I've got 8 of those, and also like on the outside of here I've got concrete blocks, and then I've got sandbags here as well. I had to adjust these ones, but yeah, the wind literally lifted up the workshop. The prevailing wind direction is kind of that way here. I've got some shelter, so the kind of building goes to about here, and then this end, this about 5 foot or so, is really exposed from the sort of prevailing wind. And you can see here we've got like a wooden edging, and then it's into the ditch. It basically lifted up the workshop, pushed it that way, and it's pushed just past that point there. The next bit of wooden edging has just been wiped out, broken, and I literally had to come in and hoof the workshop back into place, move all these things over. I've got my sort of consumable storage over there. I had to move that out of the way and just hoof the workshop back again. And in the end, then I actually got my tow rope, and I literally tied the frame onto this crash bar. Fortunately, I own this car, so there's not risk to a customer's car. But yeah, I tied the workshop down, and the wind was howling through. Hence, I've got some sandbags there that were on the floor, but the wind just kept lifting this up. So I put some ramps there just to give the wind somewhere to go. But yeah, wow, that was kind of interesting. I was hoping to do a bit of work on the car over the weekend, but that didn't happen. So, but here we are. Right, so now we can crack on with it. So what have we got left to do? So this air dam I've just put on. So real final steps now, to be honest. So down the back here, so here we've got, this is the BMS cable for the battery and the main battery power cable, orange cable. So if you can see, and the light's not amazing, but oh, there we go. So you can see there's two nuts there, and then there's a little, so that bracket, ooh, yeah, is meant to be on that nut for the BMS cable, and then that is the main battery high voltage cable, which has just gone out of focus. There we are. It fits on there, so they need putting in place. And then there's another bracket just in front of the battery that holds them on as well. And also this BMS cable's got a little bolt on the back of the motor as well to hold it in place. So that all needs tidying up. We've got the motor cooling fan fits on there. We've obviously got the headlights and bumper to do. We've got arch liners to do. We've got under trays to do. We've got the scuttle panel, so there's two parts to that. It's kind of the underneath bit that slots in, and then the brake fluid reservoir bolts onto that. And then there's the top sort of scuttle bit and the wipers and foam trims and stuff. Obviously wheels, I need to do the tracking, and it's due for an MOT tomorrow. So basically, this car's getting fixed today, and it might be a late night. There's not too much there, it just depends what happens with other things that are going on today. I've got some child-related things to sort out. But yeah, it's got to get fixed, so it might be a late one, but yeah, probably just with a bit of a road test and sort of doing the tracking and things like that. But we shall see. So I'm going to crack on, and I'll catch you in a bit. All right, cheers. Okay, we're getting somewhere. My glove. Yeah, so we've got headlights on. I've got two of the under trays on. It's got 3 under trays on a Zoe, and I've got the front one remaining. Obviously got the bumper left, front arch liners and wheels, and that is it. Then we get this outside and yeah, just see how it runs basically, because we've done quite a lot of work on this car. We've obviously fitted new bearings in the motor, so stripped the whole motor apart and done those bearings, which is quite a tricky job. Done it a few times, but it is quite involved. Didn't go quite as well as on other vehicles, but we shall see. We've swapped the reduction gear as well because that was noisy, and on the steering rack, so we're going to hope there's no knocks, because we could have some fun with the MOT otherwise. So yeah, under trays on the Zoe are quite interesting. So we've got, if we just put that lamp on, so where are we? So there's one, that metal one that covers up the sort of battery connectors, so obviously make that a little bit stronger to keep that safe, and then there's this plastic one that kind of with wings that goes in front of that one, and then there's the larger one. So this is the one that fits under the sort of engine bay, and then that's the motor output cooling fan. That's where the duct goes through, which comes out the back of the motor. So that's that one, that pops out through that slot. So I have to say, if you're doing a project, anything big, I mean, I always try, if possible, to put bolts back in holes. So you might have seen, so like these bolts were in there. So yeah, okay, when you're then putting it back together, you have to sort of undo them to put it back in again. But there's no debate as to which bolt it was. And you're going to end up with a lot of bolts if you do a project like this, and you're just taking them out and, you know, chucking them over to the side sort of thing. So I always keep my bolts in tubs. It's obviously got the road wheel bolts there. This is front under tray. I know it says bumper on it, but I've reused this tub. And then this is like the arch liner, sort of, yeah, front arch liner, so it screws onto the bumper and then it pops in. So yeah, so that's a few of those, and we're going to get that back together and see how we go. So yeah, hopefully shortly we'll be driving this car and see what happens. All right, catch you in a bit. Well, exciting news, the pots are back on the shelf empty because the car looks like this. If I can step back. So yeah, we are back together. This is cool. So all under trays are on, everything is on basically. So the next job is to drop the car, torque up the wheels, and then go for a little drive. So it's not tracked, other than roughly. So it's not going to be perfect, but we just want to see if there's any noise, any knocks over the bumps, that kind of thing. It looks like that one's going this way slightly, but not too bad. We shall see when we get the wheels down, double check the tracking and everything. But yeah, test drive, short test drive first, see if it's making any noises. Whew. I always get a little bit nervous at this point, but yes, we shall see. All right, cool, catch you in a bit. Okay, so here we go. We're gonna fire it up, back it out of the workshop, and see what it sounds like. Right, the wipers seem to be on. Let's just knock them off. That mirror is completely in the wrong place. Sorry. To see where I'm going. I think we've got one mirror folded in and one not folded in. Oh, we've got one mirror stuck. Right. One moment. I'm just going to sort my mirror out. Okay, the mirror issue is resolved. I'm just going to put it in reverse and swap hands. We're going on a private road, so that's okay. Well, other than the brakes, so far it doesn't sound too good. I've just got another car behind me. So we're going to have to just do a little forwardsy backwards, but I want to do some speed really. And see. Try not to run over a pallet. Right. Yeah, we'll be alright. Right, just getting it up here. We can. Well, it sounds alright so far. No noise at all from the motor, which is really good. So whether that front sort of suspension-y knock's gone, I'm just going to turn off the pedestrian thingy so that any noise we hear is the motor. Yeah, no noise at all from the motor. Can't hear anything from the front suspension. Tracking is miles out. That's not a surprise. But yeah, that sounds, well, sound of silence, pretty much. Just gotta use my other hand. In one moment. Just go backwards. Oh, there's a truck parked halfway there, right at the end of the lane. Right. Let's go back up and see how we go. Sounds pretty good to me. Can't hear any bumps, any knocks over the bumps. Oh, I think we're good. I think. Yeah, man. Sounds good to me. Well, sounds fantastic. Oh, the Mrs. Advent calendar's just fallen off the shelf where I hid it. Right, fantastic. Well, that sounds, well, it sounds brilliant because it's not making a noise at all. So there was no knocks. The front suspension had a lot of knocks. I suspected that was a steering rack. You could really feel it through the steering. So that does sound like that's the case. And the motor is absolutely silent. And the reduction gear is silent, which is a fantastic, massive relief. You can sort of spin it, you know, when you start it up. But, yeah, you can't, you know, you're just turning the motor slowly. You don't know really if it's any good, really. I mean, that test drive really doesn't tell us if it's perfect, but sort of so far so good. So I am happy with that. I'm going to do the tracking, and basically it's going for MOT tomorrow. And yeah, we shall see what happens. So yeah, so far so good. I think this car will live to fight another day. All right, cool. We'll catch you later. Cheers. Okay, well, this car's been for its MOT. I did a couple of short drives, just yeah, just literally sort of down to the road, just so everything kind of, you know, looked okay. Went to the MOT and I've just picked it up, and there we are. We've got a pass. So yeah, the MOT tester commented that the front discs are a little bit corroded, that we could put discs and pads on it, but that will be up to us, but obviously meets the braking efficiency requirements, so it's got a full MOT. To be fair, the car, because it's not been used for a while, you know, the discs do look a bit, it's probably easier over here, yeah, kind of look like that. They need cleaning up. And obviously with an EV, it does mainly regen when it slows down to sort of recharge the battery a bit, so it's only that last bit of braking
where it's sort of stopping the car from a lowish speed. That actually uses a friction brake. So we've got a full MOT, and what's left to do on this car? So it needs the tracking kind of finishing off. I do my own tracking, basically because last time I went and got it done somewhere else, and they charged me 47 quid, which I thought was quite a lot. And I do it myself, basically. It takes a little bit longer, but doesn't cost 47 quid. So I might do another video actually on how I do tracking, because people will probably be interested in that. But yeah, so the front wheels basically are tracked versus each other. So it's driving straight. It's just versus the steering wheel. So the steering wheel's a little bit off center. So that needs correcting. So I might actually do a video on that tomorrow. But yeah. And the other thing is a bit more testing, basically. It also needs aircon gas, but just in terms of vehicle function, yeah, I need to do some more testing. So you'll also notice that it's got different wheels on it. These are the original wheels from the car, and then I quite like those ones, so I put them on it. And basically it needed a new tyre, so I had the new tyre put on the original wheels, and then I just need to get them swapped over, so they'll all look like that eventually. And then when it's ready to sell, it's kind of standard rather than looks like someone's put different wheels on it. Yeah, and then testing. So I am going to go and basically drive it at speed. I'm going to go on the nearest A road, hammer it up a couple of junctions, turn around, and hammer it back down again, and just put maximum torque through that motor, because we've had that all apart. There's a fine tolerance with the position sensor, so we just want to know that that's all working, and if there's any issues or not. So hopefully all be good. I'm going to go and do that now. So yeah, it also needs regassing, because it's got a heat pump. We've only got limited heat at the moment. Zoes have an additional electric heater for cold temperatures. Unfortunately it's cold, so I'll actually get a little bit of heat in the car, but yeah, I will need to take it and get it regassed as well once we know it's all good. So I'm going to go and hammer it, and I'll let you know what happens. Right, cool, cheers. Okay, so I've just hammered it up on a road, obviously at the national speed limit. Yeah, so it takes about 5 minutes or so to get to the A road, and then did a good half an hour with a turn around in the middle. But basically, yeah, all good. There's no vibrations, nothing untoward, and all sounds really, really good. So no knocks or anything from the front suspension. So that was definitely the steering rack. And it kind of there wasn't many things left on the list, because we've done the lower arms both sides, drop links both sides, and it still had quite a severe knock, which you could also feel when you tried to move if you kind of move the steering wheel that way, hold it each side and kind of rock it that way. Yeah, rock it horizontally. Yeah, so that definitely was that. So it is all good. Yeah, no faults at all. When I came back, the motor cooling fan was on, probably not surprising, because I was doing the full national speed limit, should we say. So but yeah, absolutely fine, and no vibration from the motor. Occasionally with the motor rebuilds you can get a little bit of vibration at certain speeds, which we suspect is worn reduction gear, but obviously this has had a nice really low mileage reduction gear put on it, so yeah, we wouldn't expect any noise. That's what we wouldn't ideally want, any noise, and that's perfectly what we've got. So yeah, I guess yeah, who wants a cheap Zoe? Yeah, so I need to do the wheels, get it put the original wheels back on, get it regassed, and also do the tracking, finish off the tracking as well, so that the steering wheel's straight when you're driving along. But I will do that over the next few days. They make fantastic second cars, these Zoes, because they're the Zoe 40, so based on your sort of 3 to 4 miles per kilowatt hour, even in the winter you can get well over 100 miles out of them. They have the heat pump, which helps that winter range. So as a second car, absolutely fantastic. To be honest, this was our second car. We drove it far more than our sort of big, you know, summer camping petrol car. So yeah, they're just so cheap. Charge them up on overnight electricity. Mine's about 7p. So you know, it's like 2p a mile basically. It's insane. Whereas our big old petrol car, something like, well, it's over 20p a mile, probably 25p a mile. So they're ridiculously cheap, and this one's literally had everything done on it that's common on these cars. So yeah, I guess shortly this will be up for sale. I'll keep driving it around just to make sure that everything's good, but it's all looking good. So thank you very much for coming along on the journey. Hope that's been interesting. Any comments, put them in the comments section. I hope you have subscribed, because that would be fantastic if you do, and I hope you've enjoyed it. Yeah, and I've started the next project, so we'll see what happens with that one. But yeah, this one's been interesting. I knew it was going to be fairly complex just given the mileage, but yeah, 116,000, and this will do plenty more. And it's battery lease, this one. Therefore, if there's any issues with the battery, they would be covered anyway. So as a second EV, or as a you know, an EV to buy, used EV to buy, I should say, I think it's a fantastic choice. So there you go. Yeah, let me know what you think, and I will catch you later. Cheers. Okay, so this car is all done. Just doing a few final checks. It needed regassing, and also the wheels. I'd put slightly different wheels on it, and just to sell it, basically, I put it back to the original wheels. But what did it cost to do, and was it worth it, really? So just to recap, this car developed a pretty nasty motor bearing noise, quite common on these. So this is a late 2016 Zoe ZE40. Motor bearings are a weak point on these, and you know, they are quite repairable, but finding someone to do the work can be a challenge. But it's one of the things I do. This was actually my wife's car, and she's got the ZE40 now. It's featured in a previous video. So but yeah, this is all done. So was it worth it? So costs first of all. So the actual bearings for the motor itself are about 25 quid each, the ones I fit. There's two bearings on it, one at each end of the rotor, and they're not the easiest to get hold of, but once you find them, the company's got them, and I get, you know, about 4 or 5 at once of each kind of thing, 4 or 5 sets, then that's fine, and that cuts down the delivery and everything, so it makes it about 50 quid for motor bearings. So not too bad. On the motor, it's got a brush kit, because it's sort of externally excited, the rotor. It doesn't contain any magnets, as you'll know from previous videos. So that brush kit is really essential to change. It can cause faults on the motor controller if you don't change those brushes at the same time. That's about £110, that brush kit, so more expensive than the bearings. And also the other essential thing when you're doing the motor rebuild is there's a metal ring inside the position sensor, and it's just bare metal, and that can rust, and that's like 12 quid. So basically really wants doing at the same time. So we also put a steering rack on the car. The steering rack I actually had left over from another Zoe. It's one that I thought needed a rack, but actually it was just front suspension. But actually, as it turned out, the track rod ends were really in a bad condition on that car, so I borrowed the track rod ends, so like the bits that connect from the steering rack onto just behind the wheel. Yeah, so I had that rack because I just used the track rod ends off it. Just looking back, I bought that for £46. They don't suffer from any issues though, so that there's quite a lot of them around. So yeah, that was fairly reasonable. So that basically got the car working, and it needed a tyre for the MOT, and tyre was 55 quid because they're a real common size. They have to be correctly EV rated. They don't have to be a specific EV tyre, but they have to be an XL weight rating, so the 91 is it, I think, but the XL reinforced tyre. But you can still get good rated budget ones that meet that, so that's fine. And then the MOT was 35 quid. So all of that to actually get the car working and MOT'd in terms of parts, kind of outlay costs, was £608, which is quite reasonable. But realistically, the biggest expense on this was time. So it's probably about 15 hours, this. So as you've probably seen, you've got to get this whole front end off, get the stack out, strip it all down, and that is a long job. So doing that motor stack out, and then putting it back in again, we're probably talking, that's a sort of 8 to 10 hours, something like that. And then you've obviously got to like sort of strip that stack down, get the motor out, check it over, start taking it apart. That motor, 2-3 hours I'll probably spend rebuilding a motor, and I want to do it properly. You know, it is a critical component, and I want it to be reliable. I want this to be a reliable car for someone, so we do that properly. So yeah, it's a sort of 15 hours now. You know, this is what I do for a living, but I enjoy it as well. I don't sort of invoice myself for my hobbies. But realistically, if you're buying a car that's got a motor fault, you got to think about what that's going to cost you in labour. The car also, because it's high voltage, needs high voltage isolation, which isn't very long, but you just have to be a little bit switched on. I've obviously worked on a lot of Zoes. If the motor wasn't repairable, rebuildable, which they're about 50-50 when I strip a Zoe motor, whether I rebuild it or we don't, because it's got something concerning on it. Then we would have to find another motor. So your sort of minimal costs on the motor, your brush kit, bearings and position sensor, that's about just over 170 quid, 172 quid, is then going to become, well, it's what you can find. Sometimes you have to buy a whole stack for a Zoe, which can be 1,000, 1,500 quid. So yeah, I mean, for me, this was my wife's car. It wasn't drivable, it wasn't usable. And what's it worth then? Well, what is it worth? 500 quid, £1,000? It's battery lease as well, which is kind of good on a car because it's done 116,000. But yeah, it wasn't worth a lot. It's now worth, well, 3.5 grand, I reckon, something like that. I'm going to put it up for sale soon, so we'll see. But yeah, so it's definitely worth it for me to do it. But obviously, I'm not billing myself the labour, so it's something I already own and it's going to go up in value. But realistically, if you're going to buy it just to work on it, I think it depends on whether you can do the work yourself, to be honest, as to whether it's worth it. But yeah, that's what it took. Any questions, let me know. Hopefully that's interesting. I'll put a full video, the full video story of this one up shortly, because this is it. But yeah, I'm literally going to need to good wash, get it valeted, get the seats cleaned and everything, so it's all fully ready to go. I'll keep driving it round, keep charging it, keep using it, you know, just to make sure everything is good for the new owner. But yeah, this is ready to go. It's got a few sort of scrapes. It needs a good polish because it's got like a little scrape along, you just about see along there and stuff. Just normal stuff you get with any car, really. And it's got one where I reversed into a post, beautiful, and then the bumper sort of deflected and it took that. I'll try and pull that out a little bit, but these are fantastic cars, fantastic second cars. It obviously has done quite a few miles, but the motor's been rebuilt. Previously, sort of in the last 6 months or so, because it was developing that front end knock, which is commonly the lower arms, the ball joints on the front lower arms, or the drop links, because it was sort of getting near the MOT. This is before the motor started making a noise. I did the front lower arms, both front lower arms and drop links before kind of this rebuild. So, you know, although this car's high mileage, it's battery lease, so if there's a fault with the battery, Renault get to fix it. The motor's been rebuilt, the front suspension's all been done, so literally all the common stuff's been done. And a car like this, so in the winter, this will still do 120 miles range on a full charge. In the summer, you might get 150, 160 miles out of it, something like that. So as a second car, fantastic. It doesn't have DC rapid charging, because none do at this age with a Zoe, but being a ZE40, a really usable car. I think they make great second cars. I'm very tempted to try and sell it to my mum, because I think it's pretty cool. These ones obviously, also being the ZE40, had the 5-star Euro NCAP safety rating as well. I think they're great, to be honest. But I guess we'll see what happens when I try and sell it, see if anyone else thinks it's any good. But yeah, I hope that's interesting. Any comments, let me know. And also, just to let you know, I've just started channel membership. So basically, producing free videos just for general content is fine. I'm just recording what I do. But where I have to go out of the way to sort of pay for information or do something that's more time consuming, it's just not viable to just make it a free video. So I've started channel membership. It's really cheap. It's literally as cheap as you can possibly make it on YouTube. It's things like priority chat, there's community only chat, and then there's some member only videos. So if you're interested in more of the sort of how-to stuff or actually technical information on the Zoe, stuff that you have to pay to access, you know, sort of like what fluids to use, what products I recommend, that kind of stuff, they're going to be in member only videos. So yeah, check out the link in the description, and yeah, catch you later. Cheers.